Hi guys, in this session you are going to learn about procedures in SAS. Procedures are used to processing the existing data for creating output. It means we need a data set for any procedures in SAS and we processing that data set for creating output. In that, first one Proc Freq, second one Proc Means, third one Proc Format, fourth one Proc Transpose, fifth one Proc SQL, sixth one Proc Dataset, seventh one Proc Import, eighth one Proc Export, ninth one Proc Sort, tenth one Proc Univariate, 11th one Proc Append, 12th one Proc Copy, 13th one Proc Printto, 14th one Proc Print, 15th one Proc Compare, 16th one Proc Report. Now we are explaining these procedures one by one. In that, first one, Proc frequency is nothing but counting the observation in variables. To explain about Proc frequency, we take example from SAS help.class. I named the dataset demo, set SAS help.class and run. We are running this code. Before opening dataset, check log is clear, demo dataset. Here we have a 5 variables name, sex, age, height and weight. Now we are applying frequency on one of these variables. And one more thing, before frequency we must sorting the variables on which we want to apply in frequency. Proc sort data equals to demo by age. On age variable I want to apply proc frequency. So before starting proc frequency I am setting that variable. Log is clear. Now we are applying frequency. Proc frequency is used for counting proc frequency. Data equals to demo tables and which variable you want to counting the observation we should represent in the tables and run. Here we are applying frequency on age variable in demo dataset. Before we have to sorting that variable. Now we are running this code. Here frequency and percent, cumulative frequency, cumulative percent are the default variables when we applying proc frequency, and on age variable we are applying frequency. And what does it mean here frequency? Frequency is nothing but counting on observations. Here on age variable we have a 211 ages and we have a 512 ages and we have a 313 ages, we have a 414 ages like this, and a percentage of that particular observation regarding to the variable, and these are the percentages of that particular observation. Then cumulative frequency, already you know the cumulative frequency. Here the first one is a 2 and a 5 plus 2 equals to 7, it represent. Then 7 plus 3 it represent 10. Like this, at the end we get number of observation in that particular variable, and at the same time the cumulative percent is nothing but 10 plus 26. Here is the 36. This is the first one, and 36 plus 15 52. Like this we are getting cumulative percent, and these are the default variables when we applying proc frequency on a variable in a particular data set. Here we can apply proc frequency on 2 variables at a time. Then how it will be? And we know that before applying proc frequency we must sorting that variables. Here we are using the 2 variables, so we have to sort the 2 variables separately. And first proc sort data equals to demo by age and run, and the proc sort data equals to demo by sex and run. Here we are applying proc frequency and 2 variables, those are age and sex, and I use more than one variable in a table statement. Proc frequency data equals to demo tables age into sex and run. Here we are applying 2 variables. Simply we are getting output here, and here we are getting on 11 age 1 is a female, 1 is a male. On 12 age 2 are the females and 3 are the males. And here first one is the frequency, is nothing but this first one is the frequency. percentage. This first one is the percentage, row percentage, this is the row percentage, column percentage, this is the column percentage. Like that we are getting each and every observation on age variable. Simply we are getting the countings of age at that particular sex variable. Now here we are getting some default variable here. Those are percentage, frequency, row percentage, column percentage, like this. Now if you want to remove or restrict that particular variable in the output also, then how it will be? Here proc frequency data equals to demo tables age and sex slash no call. It means in the output I don't want the column percentage, and run. We are running this code. Here there is no column percentage here. Before we are getting column percentage here. Now we are remove that call percentage simply by no call. Like that we can remove another default variable from that output, and proc frequency data equals to demo tables age into sex slash no row. It means there is a no percentage when we are applying on this table. Now there is a no row percentage. And the next one we can remove another one also, that is the tables age, sex and no percentage. Now we are running this code. It means we don't need a percentage variable in the output. Now there is a no row percentage in this output, and we can apply more than one removable variable at a time also. Then how it will be? Data equals to demo tables age into sex slash by no call space no row space no percentage, and run. Like this we can remove the default variables from the output. Here we are getting only frequency, and one more note here, we can't able to remove the frequency. In the next one we can list the observation, and then what does it mean, then how it will be? And proc frequency data equals to demo tables age into sex slash list. Simply before we are getting the output like this, like the crash table, and now we are getting like a list. When we are applying list, we are getting this like a list simply. And the 11 we are getting females 1 and 11 males are 1, and 12 females are 2, and the 12 males are 3. Like this we get the output as a list when we are applying list in the tables. And the next one we can filter the data. Proc frequency data equals to demo tables age and sex where sex equals to m, and run. Simply on the frequency we can filter that particular males data from the output. Here we are not getting any females. Why? Because we are filtered that particular data. And the next one, convert output into data set. Simply we can convert that output window into like a data set. Then how it will be? Proc frequency data equals to demo no print. Here no print means we don't need to print that result in the output window. And the tables age into sex slash out equals to demo to run. Here simply by using out equals to we can convert that output into dataset. Before opening dataset, check log is clear. Now we are opening demo 2. Like this we can convert that particular output into dataset simply by using, we can give label and a title at a time in the proc frequency. Then how it will be? Proc frequency data equals to demo tables age and sex and out demo 3 label. On sex variable I applying label, that is the gender of the student, and the title is information about student, and we are running this code. Here the label of sex variable is gender of the student, and the title is information about students. Like this we can give the title and label of the dataset also. Second one, proc means. The definition is the means procedure provides data summarization tools to compute descriptive statistics for variables. Simply proc means equals to summary statistics. They are m, mean, median, minimum, max, standard deviation. For explain about Proc Means, we take example from SAS help.class and enable the dataset demo. Set SAS help.class run. Before opening dataset, check log is clear. We are opening demo. In this dataset, we are applying Proc Means. Proc Means are simply finding the summary statistics of variables. The first one is Proc Means. Proc Means, and the very important note is Proc Means is only applicable on numeric, and Proc Means data equals to demo. On the demo dataset, we are applying Proc Means, and where is a statement to finding the means of a variable, and why only for numeric we can't able to apply means on character variable, and run. Here these are the default variables when we applying Proc Means, and here the means procedure analysis variable is age, and here n is nothing but number of observations in a variable. Mean is nothing but sum of observations by number of observations, and for standard deviation we have a formula. For now, no need to explain about this standard deviation here. Minimum is nothing but the least observation value in a variable, and maximum is nothing but the max observation value in a variable. These are the default variables when we applying Proc Means on a data set. And we can apply more than one variable in a where statement to find the means. Then how it will be? Proc Means data equals to demo where age, height, and run. Like this we can apply number of variables at a time by using where statement. We are applying on two variables, age and height, and for those two variables we are getting n is same for both variables, and the minimum is the independent on observations, and here the 13 is the value of mean, and here the 62 is the value of mean of height variable and age variable, standard deviation of both, and the minimum value is 11 in the age variable, and 51 is the minimum value of height variable, and maximum is the 72 for the height variables. Like this we can find, and we can also grouping the variables based on the Proc Means. Then how it will be? By the by statement we are grouping the variables on Proc Means, but before applying by we must sorting that by variable, and Proc Sort data equals to demo by sex and run. In the by variable we can use both the character and a numeric here, and Proc Means data equals to demo where age and by sex. Here simply by statement is used for the grouping the observations. Whenever we use the by statement we must sorting that by variable before we applying means. Now we are running this too. Here we are grouping differently based on sex variable. Here we have two types of observation in a sex variable. One is the f and another one is the m. Based on sex we are grouping the variable, and the number of observations are 9, and in that we have a mean based on f only, and based on m we have a number of observations are 10, and mean is based on that only. We get different values for standard deviation and mean, and minimum value and maximum value also different. Why? Because we are separate that number of observation based on the particular variable. Like this we can grouping the variables by using by statement. Whenever we use a by statement, that purpose is for grouping, and before using by statement we must sorting that by variable by using Proc Sort. Here we are getting by statement within two tables, but we can set these two tables into one table by simply using class statement. Then how it will be? Class compare the variables Proc Means data demo class sex where age and height and run. Observe here, before we are applying by statement for the grouping variables based on the type of observation in a one variable. Now by applying class, we are getting the two tables in a one table by using class statement simply. Or you observe here, we have a 9 observations, 10 observation. By applying class, we are getting 9 and 10 here simply by using class statement. Here the difference is by using by statement we are getting two different tables, but by using class statement it's the same for the grouping but in one table. Now we can convert this output into one data set also. Then how we convert this into data set? And proc means data equals to demo, and here we are using a no print. It means we don't want to print this output in output window. And a class X where age, height, and output out equals to demo1 and run. In the previously proc freq also we are using out statement, and here we are using the out statement in some other way. And before opening dataset, log is clear, we are opening demo1 dataset. Here these are the default variables when we applying the proc means to convert into a dataset. And this is an age variable. On an age variable we are applying proc means, and height variable also. These are the statistics. What are the statistics? N, mean, maximum, minimum, standard deviation. We are already discussed about what are those. And when type underscore type is 0, when it's on total number of observation. Here the total number of observation, and but when it's separately it's giving 1. Got it? These are the 9, these are the 10, and we can print particular statistics in the output also. Then how it will be? And simply proc means data equals to demo median. I need only median in the output. Class X where age and height, run. Are you got it? I need only one particular statistic in output. Are you get it? Here we are getting only median in output, and those are we are applying class. That's why we are getting in one variable, both in a one variable, and the number of observation, and these are the variables we are applying here. Median is nothing but middle value of a numbers, and for better understand we just draw a line between the females and males here. And here the females, the total number of females are 9, and 9s are nothing but it's an odd number, so it's easy to find the median, nothing but middle value of a number. Here 11, 12, 13, 15 observations are there, and 1 to 9 observations are there. The middle one should be 5, so the median of age is 13. Now in the males, the totally 10 observations are there. It means this is an even number. In this situation what we did, we just take the two middle numbers 13 and 14, and we find the mean value for it. We know that mean value, the sum of observations by number of observations. By this we get a median value for males also, that is 13.5. We can get another statistics also. Then how it will be? Proc means data equals to demo mean, class X, and where age and height, and run. Here we are getting median. Now we want to get only mean. Then how it will be? Yes, like this we get only some particular statistics in the output window, and we can convert this particular one statistics into output also. Then how it will be? Proc means data equals to demo, and no print, class X where age, output out equals to demo2, simply median equals to, and run. By this out statement we are converting this output into dataset, and by the median equals to we convert only in the median into output. Then how it will be? Before opening datasets, log is clear, demo2. These are the median values. Here the frequency, already you know what is the frequency, nothing but counting of observations in it. And this is the type. When on a total it is a 0, and when is a particular observation, 6 and m, we are getting 1 and 1. Here we are not getting this as a median or mean or whatever. It means we didn't identify suddenly when we see this, so we need some name for it. Then how we give a name, particular statistic name for this variable. Proc means data equals to demo, no print, class X, var age and output out demo 3, median slash auto names and run. Before we are getting directly by age, on age variable we are applying median, but we didn't find what is this median or mean or whatever. By overcome that situation, we simply give auto names. Then what will happen when we give this? Before opening dataset, log is clear, demo 3. Here age underscore median. What does it mean? We are applying median, so it gives a median auto name. Okay, like this we can name a particular statistics and a particular variable. Now, and we can use a more than one variable also. Then how it will be? Proc means data equals to demo, no print, class X, var age and height out demo 4, mean equals to space, median equals to space by auto names. And by simply means we get only particular means and a median here. By the auto names it naming that variable. Then how it will be? Before opening dataset, log is clear. Here we are applying an on age mean, on age median, on height mean, on height median, and we are getting separate values for both. And a frequency, you know already, when on a total number of observation it gives 0, total of number of observations are 19, and on female observations are 9, male observations are 10. Like this we are getting output on particular statistics. And the next one, here we are giving class by var statements, but if you are applying directly proc means, then what is an output we get? Proc means data equals to demo and run. We didn't give any particular statement like var, class and by. Then what is the output we get? Here simply when we give without var or by or class or whatever, it just consider total number of numeric variables from the data set. Why? Because means only consider the numeric variables. That's why when we are not mention any particular var, class or by, it takes all numerical variables and find the statistics for those. Third one, Proc Format. The definition is Proc Format is a procedure that creates your own custom formats or user-defined formats. Simply, we can create our own formats by using Proc Format. Before going to know about the Proc Format, first we have to understand what is the purpose. Now we have to find what is the purpose of it. I named the dataset grade at mlist. If 70 to 100, then grade of E is a A1. And if 60 to 70, then the grade should be A. If 50 to 60, then grade should be B. If 40 to 50, then grade should be C. And if 0 to 40, then grade should be F. Or you got it? I am just assigned to English language of by grading 0 to 40 is a fail, and 40 to 50 is a C, and a 50 to 60. Like this, I gave grades to the subject marks to individual subjects. Now at the same way, I have to create of each individual subjects. Like here we have a math, we have a science, and we have a social. Now I am creating those also. Simply at the same grading for the math also, and the same grading for science also, and the same grading for social also. And run. First we have to run the list. Before opening dataset, log is clear, and here mlist. Here we have created our own student list, like with the 5 different of students name and random subjects of English, math, science with the random of marks. Now we are running this code. Before opening dataset, log is clear, and here is a grade. Or you get it? We are getting grade for each individual subject based mark of student got. Now here, this is a very hard to find each subjects, and for example for each class, each individual class have a different subjects, and here we have only taken 5 people, but in the real situation we have a 100 number of students, and this is an impossible to each and every time by using if statement to create a grade system like this. To overcome this, to solve this problem, here we can create our own grade formats by using Proc Format. Then how it will be, how it works? Simply, Proc Format value is a statement used for creating a format, and the grade is a format name. Here I am just giving 70 to 100 is A1, 60 to 70 is a A, 50 to 60 is a B, 40 to 50 is a C, 0 to 40 is a fail, and run. Like this, we are creating our own format here. If the student, whatever subject, whatever the student is there, if the student got 70 to 100, then it should be A1. If 60 to 70 A, like this, we are applying grades. Now we are running this. Okay, here we are formats are created. These are the formats, we done it. Now what is we do? We just simply applying under data. Then how? And I named the data set updated mlist, set mlist grade underscore e equals to put. Here we are using the put statement, and here the subject is the English and grade is the format. Like this we are applying format to the new variable. Here grade underscore e is the new variable, put is a statement, and this is a target variable, and this is our format. Now like this we are creating grades for all existing subjects by new variables. Grade underscore m equals to put maths and a grade, and the same way for the science, put science is our target variable here, and just like that social, grade, and run. Here first we have to create our own formats. Now we are applying that formats to the data set. Instead of all these lines, we are just write these 4 lines for grading system. Now we are running this code. Before opening dataset, log is clear. Just observe here, this is our u underscore mlist by using proc format. This is our grade table by using if statement. Result is same, but the procedure is become easy to apply on the data. Got it? This is the purpose of creating proc format. Simply instead of writing these all lines, we are just writing one proc format for all those, and we are just applying by the put statement here. There are 3 ways to create format. The first one is character to character. It means if the variable is a character, and whatever we create the format also should be a character. And while creating a character to character proc format way, we have to remember some rules while creating it. What are those? The first one is we should use the formats, and we need a symbol, is a must and should, and we have to use the value statement while creating a proc format, and we have to use the put function in it. And the next one is numeric to character. What does it mean? The variable in the dataset is a numeric, and we are creating a character proc format. And what are the rules while creating it numeric to character? And it also should be formats, and no need of symbol while creating numeric to character, and value statement is used for it, and we use the put function for creating numeric to character. And the next one is character to numeric. What does it mean? The variable in the data set is a character, and we are creating a numeric proc format, and we have to use the in formats while creating a character to numeric, and the symbol is no need, and we are to use the in value statement while creating a character to numeric, and we have to use an input function here. Got it? While creating any proc format, we have to remember these 3 ways, and we have to remember all these rules while creating any proc format. And before creating proc format, I show you the dataset for explain about a proc format, and I named the dataset demo and set SAS help.class run. Before opening dataset, check log is clear. Now, based on the type of proc format, we use these variables in the different ways. Now, we start the character to character proc format. Proc format, value statement. This is the character to character. In the character to character, we have to use value statement. And this is the dollar symbol. Dollar symbol is needed while creating character to character. And m equals to male. This is the dataset observation and this is the format. What does it mean? Here is the character, here is the character. The dataset observation is a character. We are creating a character observation by using proc format. So this type of proc formats we call it as a character to character. Now the second one is f equals to female and run. We are running this. Here we are getting one folder gender. Gender is our format and when f is there female and when m is there male. Now we are implement this format in the dataset. Then how it will be? Data character to character. I named the dataset. Set SAS help.class. Gender is a new variable and a put function we have to use while creating a character to character. And sex is our target variable. In the sex, so we have a m and f. Okay, now what we are creating, when it is m, it is a male, when it is f, it is a female. So it is a, both are the character. Here is a character, here is a character, so it is a character to character. Now we are running this code. Before opening dataset, log is clear. Here observe here, when m is there, it represented by the male, and when f is there, it is represented by the female, and this is a character variable, this is a character variable. So this type of formats we called as a character to character. Now the second one is numeric to character. What does it mean? In the dataset, the variable is a numeric and we are creating a character variable. And a proc format, value is a statement here. While creating a numeric to numeric, value statement is there. And the groups is the format name. In the age, if it is 1 to 12, then it is represented by the group 1. Okay, and here is the numeric variable, that's why is the numeric, and here we are creating a character variable, so it's become a character. And while creating a numeric to character, no symbol need, that's why we are not place any symbol here. Before character to character, the symbol is needed, that's why we place a symbol here. Now 13 to 14 is a group 2 and 15 to 16 group 3 and run. We are running these again in the format groups is there. Okay, here 1 to 12 group 1, 13 to 14 group 2, 15 to 16 group 3. Like this the format is created, and now we are apply this format in a dataset. It has help.class and age 1 is a new variable and a put function we are using, already we mentioned, where while creating numeric to character we use the put function. Now age is a target variable here and a groups is our format. Okay, whatever you mention here, the name, it should be the format name. And while applying this format to the variable, we have to mention the same name with a dot and run. Before opening dataset, log is clear. Numeric to character. Here from 1 to 12, wherever 1 to 12 is there, it should be mentioned by the group 1. Okay, and a group 2, 13 to 14, like that it is created. Now the third one is character to numeric. Then what does it mean? The variable in the dataset is a character. Now we are creating the numeric variable by using a proc format. Proc format in value statement, while creating a character to numeric. Okay, we have to use an in formats, and the statement is a in value. Now we use an in value statement for creating a character to numeric, and a number is our format name, and capital M, this is a character, and we are creating a numeric, so 1, and F is a 0 and run. Here whenever M is there, it will be represented by the 1, whenever F is there, it will be represented by the 0. Here another format is created, the name is a number, and here F is there 0 and M is there 1. Now we are applying this format in the dataset. Then how it will be? Character to num, and gnum is our new variable, and input, whatever we mentioned already, we have to use an input function while creating a character to numeric, and sex is our target variable, number is our format, whatever we mention in the name that should be mentioned here also, and run. Before opening dataset, log is clear. Now we are opening character to numeric. Here, whenever m is there, it will be represented by the 1. Whenever f is there, it is represented by the 0. Now, if you want to save these formats permanently, then how it will be? Proc format library equals to SAS user, and value statement here, gender, m equals to male and f equals to female, and run. Which type of proc format is here? Character to character. Okay, got it? Character to character. Here in the character to character, we have to use a value statement, and we have to use a symbol, dollar symbol here, and we have to use a put function for while applying in it. Okay, now we are running this. Okay, now this one is not created here. It will be getting in the SAS user and formats gender. Now it will be created permanently in the SAS use folder. Okay, if you close this session also, again we can able to see this gender folder here. Okay, now what is the difference between these two proc formats? Here we didn't mention any library here, but here we have mentioned some particular library. Now the applying scenario is a different for this type of proc format. Here whenever we creating a proc format like this, it should be saved in the work library, but here we are mentioned for some particular library. So while running also we have to mention that particular library. Then how it will be for running the above format? It means if you save format in a particular library and the running session and the running the code also some different in it, then how it will be? We have to use an option format search equals to SAS user. Now we have to write a data set SAS help.class, and grp is our new variable, put is a function here, and sex is the target variable, gender is our format. Run. Or you got it here? What is the difference between this type of format creating procedure and this type of format creating procedure? Here if you not mention any particular library while creating a proc format, we directly run the data code. Why? Because it is saved in the work library. But whenever you mention the particular library while creating also, we have to mention this option format search equals to whatever you mention library here, we have to mention here. Now we are running this code. Log is clear. Work S is created. S dataset. Got it? A male and female. And if you mention like this the library, it will be saved permanently, and you forget that particular library name wherever you created. At that situation, what we do for running that format? And simply options format search equals, you have to mention the libraries whatever you guess that format in that library, and data is SAS help.class grp equals to put sex gender and run. Or you got it? If you know, if you forget about the format you created in a particular library, you have to mention the all libraries whatever you know here. Simply it will be taken some from one of the library and it run. Now unfortunately the all formats are deleted from the library. Then how it will be? If you running this blindly, it will show an error. So we have to use this option no format error. Okay. Now if you write code like this, what happen whenever if the formats are deleted from the all libraries, if you use this option format no error, it doesn't throw an error. Got it? Now if you want to know the number of formats in the all libraries, okay, then how it will be? Proc format library equals to SAS user fmtlib and run. Okay, these are the libraries we created. Fourth one, Proc Transpose. The definition is Proc Transpose is changing or converting variable to observation and observation to variable. Simply we can convert the variable to observation and observation to variable. For explain about Proc Transpose, we create a dataset of student mock list. The dataset name is tracks input Serial number, math, science and social, these are the variables, and cards. These are the general mock list of a students with 10 serial numbers and math, science, social subjects, and run. Before opening dataset, log is clear. This is our dataset. Now we applying Proc Transpose on this dataset. Before Proc Transpose, we must sorting this dataset. Proc Sort data equals to trans by serial number and run. Now we are applying Proc Transpose on this dataset. First we applying variable to observation. Then what is the statement we used in that? Okay, first we applying variable to observation. Proc Transpose data equals to trans. Out is nothing but to convert this into dataset and by serial number. Why? Because we sorting under serial number only. And where statement is used to convert variable to observation. And math, science, social. Then what does it mean here? I want this math, science, social variables here and I converted this into observation. What does it mean here? This math become here math as an observation. This science become here science as an observation. The social become here as an observation. Now we are applying in it. Run. Before opening dataset, log is clear. Trans 1. Okay, observe here. Previously, mass is a variable here. In the trans 1, it become an observation. Got it? And in the same way, science, social are the variables here. When we applying Proc Transpose in where statement, the variables are become observations. Got it here? Whatever the variables you want to convert into as an observation, that should be mentioned in the where statement. Now, when we apply Proc Transpose, the default variables are name underscore and call. Now, we can rename it. Yes, it is possible to rename it. Then how it will be? How we rename those? Proc Transpose data equals to trans. Out is a trans 2 and name equals to subject. What does it mean here? Here underscore name underscore in this place, whatever the variable name you mention, it will be replaced the name underscore name. And the next one is a prefix. Prefix equals to marks. What does it mean here? Here we have a call, COL. In the place of call, whatever you give in a prefix, it will be replaced. And the same by variable, same var variable and run. Before opening dataset, log is clear. Trans 2. Got it here? What is the difference between trans 1 and trans 2? In the trans 1, these are the default variables underscore name underscore and call 1. Now we are just rename it by the subjects by the marks. For rename underscore name underscore, we just give a name, and for rename call, we just give a prefix. We convert this observation to variable. Already we discussed Proc Transpose is variable to observation and observation to variable also. Then what does it mean? Here simply we have a trans data set here. These are the observations. Now we can convert these observation as a variable. Then if you convert these marks in variable, that is a meaningless. That's why we just convert this trans 2 into again this model. Are you got it? In the trans 2, math, science are the observations. Now I want to convert these observations into variables. What does it mean? Just like original one. Now we are applying ID. Now we convert this into variables. Observation to variable. Proc Transpose data equals to trans 2. Here the trans 2 is there. Out equals to trans 3 and by serial number ID. ID is used to convert observation to variable. Keep in mind, where statement is used to variable to observation, ID variable is used to observation to variable, and run. Before opening dataset, log is clear. Trans 3. Yes, these are the original one, trans 1 and trans 3. And here name underscore name is there. If you want to rename it, just rename it, or you can drop it. Now this is task for you. Try to drop this name underscore name underscore. Now simply we just give a note here. Keep in mind, where statement is used to converting variable to observation and ID statement is used to observation to variable here. I'm giving one trick to understand what is the variable to observation, observation to variable. Simply var is used to variable to observation. Keep it in mind, var variable. Okay. If you visit my channel is first time, please subscribe my channel and share with your friends. We can apply these two statements in one data set also. Got it? Then how it will be? And data both set SAS help.class for explain about for applying both var and id statement in one data set. I get example from SAS help.class and run. Now Proc Sort, we need to sort it, run. And Proc Transpose, data equals to both, out equals to both 1, bisects. In the var, I want to age, height and weight. In the id, name. Got it? What that happened when we applying var and id here. And in the var statement, age, height and weight. What does it mean here? This age, height and weight are become the observation. These are the variables. I want to convert this into observation. That's why I gave a in var statement. Now I want to convert name as a variable here. Okay. Here name is there. I want to convert these observation into variables. Okay. Before opening dataset, log is clear, both one. Okay, got it. By the sex underscore name underscore is there and id. In the id I gave a name. All the names are become the variables here. And I gave age and height in the var statement. Previously that are the variables. Here they are converted as the observations. Got it? And whenever you give a by statement, that which should be the first variable here. Okay, in this also. And here also we give a serial number as a by. That's why the by value is the first. If you have a duplicates in the data set, while applying a Proc Transpose, it shows one error. Then what is that error? How to overcome that? Okay, and we are using let. Let is used to remove duplicate error. It converts the error into warning. And then how it will be? I created one data set for the duplicate and input. I just gave a subject, BP and heart rate and cards. Here this is the duplicate record with the same one is BP and 100. Before opening data set, log is clear, do. Okay, here this is the duplicate record 1, 2. Now, if the duplicate record in the data set while applying a Proc Transpose, it shows one error, then what is that error? And sorting is a must and should while applying a Proc Transpose. And Proc Transpose, data equals to do, out equals to transform, and by the subject and ID, BP and run. I am just converting observation, these observation to variable. Here in the log we got one error. Then what is the error? ID value 6pp occurs twice. What does it mean twice here? Twice is nothing but a duplicate in it. Then we can convert this error into warning. Then how? Just by using let. Proc Transpose, data equals to do, and out transpose and let. The remaining is same. Got it? We just applying let here. Then what happens to it? Previously when we not applying a let here, it become a error. Look at here, there is no let, and when we applying let, that error become a warning. Got it? Like this we can convert this error into a warning. And there is another way to remove these duplicates. Simply you know that how to remove a duplicate by using a no dup key. And Proc Sort, data equals to do, out loop underscore no dup key. By heart rate and run. Dup underscore, we are removing that duplicates is BP, only 100 is there. Now again we are sorting in for Proc Transpose. Proc Transpose, data equals to dup underscore out transpose by subject and ID BP. Here log is clear, transpose underscore, yes, we are getting the output. And when we applying let also we get an output in the transpose. Got it? And the same output by applying let also, just we converting that error into warning, and we are getting same output when we remove the duplicate by the no dup key also. Okay, this is the way to remove the duplicates by using let or no dup key. Now we can add two variables in a one variable. Then how it will be? For explain those, I created one data set transp and the input name, subject and marks, and simply I created one dummy data set with the name, subjects and marks and run. Before opening data set, log is clear, trans p, and now I am applying Proc Transpose to convert two variables into one. Proc Transpose, data equals to trans p, delimiter is used to between the two variables, and a name equals to marks, already you know what is the name, and out equals to out data, id, name and subject. Log is clear, out data. Okay, in the one variable we are just getting name and subject, and previously these are the observations. Previously name and subject is an observation, we convert that into variables by using id. Fifth one, Proc SQL. Hi guys, in this session you are going to learn about Proc SQL. SQL full form is Structured Query Language. For understand about Proc SQL, we take example from SAS help class, and I named the dataset check1 and I set SAS help class and run. First we run this code. Before opening dataset, log is clear, check1. Now in this dataset we apply Proc SQL with the different variations. Now first we write some basic code in a Proc SQL, that is Proc SQL semicolon create table SQL1 as. Here this table statement is used to create the dataset, and here SQL1 will be the name of the dataset, and table for create new dataset. Select is used to restrict the variables, and the name I need from check1 name. 6 from indicates where you want to data from check1. This is a check1 dataset. Now I want data from the check1, and quit. And in the Proc SQL we are not using run, we are using quit here. Okay, and one more remember thing, this is from the create to semicolon is only one line, don't put the semicolon here. In the SQL there is a total 3 semicolons. First one at Proc SQL, and the second one at the quit, and the third one between these lines. Whatever you write query between these lines, there is end up with only one semicolon. It means in the SQL there is a possibility of only 3 semicolons. And this is the basic program. We just select two variables from check1, and it just like create table is just like a out statement. The dataset is an SQL, and as select is used to restrict. Got it? Now we are running this code. Before opening dataset, log is clear, and remember one thing, before we created check1 dataset, now we apply Proc SQL on a dataset, and observe here they mention 19 observations and 5 variables, but in the SQL 19 rows and 2 columns. What does it mean? Here 19 rows represent observations, and variable represent column in the SQL. So we are opening SQL1, and we didn't do any operations in this query. We just keep these 2 variables. Now if you want to select all variables from this check1 dataset, then how it will be? We just select all variables from the dataset, and Proc SQL create table SQL2. Now I named the dataset SQL2 as select star from check1 and quit. Okay, here star indicates the all variables from the dataset. From this dataset I need the all variables, simply we put a star. Okay, now we are running this code. Log is clear, SQL2 created with the 19 rows means 19 observations, and 5 columns means 5 variables. SQL2 here, and check1 with the all variables, and SQL2 also all variables. Why? Because we are putting star here. Now we are applying some simple dataset options on this SQL. Those are keep, rename, and drop. First we apply rename, and a Proc SQL create table SQL underscore R. It means it's used for rename, and select star and use the all variables from check one and rename sex equals to gender and quit. I just rename the sex variable with the gender. I am running this code. SQL R created 19 rows and 5 observation SQL R. Okay, got it. I just rename it. Like this, we can rename the variables in the SQL by using rename option. And the next one, I am just dropping some variables in it. Proc SQL create SQLD as select star from check one and I just drop height and quit. Log is clear. SQL underscore D. We are getting the all variables except height. Why? Because we drop it. Like this, we can apply the drop. Now we just applying the keep. Proc SQL create table SQL underscore K as select star from check one and just a keep. Already you know how to apply the dataset actions. Simply we are applying dataset actions in the procedure step and run. Log is clear. SQL underscore K. We just keep only one variable. Okay, like this, we can apply dataset actions in the Proc SQL also. But there is a one note here. We can't apply where rename keep statements at a time in a SQL. What does that mean? In this simple query, we can't able to apply drop, rename, keep at once. But SQL is a simple and a very flexible. If you want to apply rename, if you want to apply drop, keep, everything is very easy to apply in a basic Proc SQL program. Then how it will be, I will explain it. Proc SQL, create table SQL as select name age, sex as gender from check one and quit. Here, first we rename. How to rename variables in a Proc SQL? Simply by using as. Here the old variable and a new variable, sex as gender. It means it's just a rename the variable simply by using as. Okay, and here in the select statement, simply if you write the variables, it will be keep the variables, and if you don't write a variable in it, it's automatically drop from that dataset. It means select will be applicable as a keep if you write the variable as a keep, and if you don't write the variables you don't need, it's just like a drop. Like this, a Proc SQL is a very flexible query for every situation, and whatever you did in a dataset options, simply it will be applicable by the single statement. Now we check some options in a Proc SQL. In that first one is to distinct the variables. Then what does it mean of distinct here? Simply distinct is nothing but to get a single observations, not a variables, single observations. And a Proc SQL create table SQL3 as select distinct age from check one. Got it? Simply I am applying distinct on age. Then what does it mean? It gives a single type of observation. Before that we are opening check one. Okay, on the age variable we are applying distinct. Then what does it mean? It gives a single type of observation. Here 14 4 times are there, but only one single 14, and a 13 like this. 13 3 times is there, 11 is some just a random numbers of time is there. And here in this simple example we only some 19 observation, but in the real time you have thousands of record. At that situation you can't get the single observations in that particular variable. At that situation simply you can apply distinct on it, and by the distinct you will get the single type of observation in that particular variable. And log is clear SQL3. Here 11 is there. 11 as an observation, how many times is there? But the 11 is a single, and a 12 is there. 12 is there some random 5 times, and 13 is there. 13 is like just a 3 times. And how many times it will be repeated? But the 13 or 14 is a single type of observation. If you want to get the data like this, you will apply the distinct. And the second one is for count the number of observation. And what does it mean? It means simply it count the number of observation, how many are there in that particular variable, and it takes the all observations. I mean, it takes all the repeated observation from that particular variable, not like a distinct. And how it will be? For count number, Proc SQL create table SQL4 as select count name as an end count from check one and quit. And here count is used to count the number of observations, and as is just the rename of it end count. This is the new variable here, and it counts the number of observations in name and store in end count. Now we are running this code. Log is clear, SQL4. Okay, here 19. Already we know that if you open the check one, there are 19 observations. In the SQL4 we are getting the number of observations are 19. Again I am telling you, this is a very simple data set. That's why it's become very easy to count the observation, but in the real time it's not like that. It's a totally opposite to the real time situation. At that situation it may be useful to count the number of observations. Now the next one is missing values with some value. Okay, for that first we create some missing values in a check one. I named the dataset check2, set as help.class. If age equals to 15, then age is missing. Okay, for filling missing values, first we created some missing values. Log is clear, check2. Here observe in the age there are some missing values. Now we are filling this missing value with some random number. Then how it will be? And for filling the missing value there are two ways. First one is by using callsec option, and second one is by using case when. First we go with the callsec. Then how it will be? By using callsec, Proc SQL create table SQL5 as select name and sex callsec of age and 999 as u underscore age from check2. Observe here we need whatever the variables in select statement, that will be the key. Got it? I need a name and sex. On the age I want to filling the missing observations with this number. Got it? Callsec and age target variable here. Whatever you want filling that in missing observation, that will be replaced. Now we are running this code. Proc SQL5 log is clear, SQL5. Okay, here wherever the missing, it will be replaced by the 999. Got it? Again we cross check with the check2. Here the check2, 8 observation is missing, and 14 is missing, 17 missing, 19 is missing. Again we are checking in the SQL5, that is 8th one, 14th one, 17th one, and 19th one. Like this you can replace the missing observations by whatever the number you want. And the second way to fill the missing values, that is the case when. Then how we apply that? By using case and Proc SQL create table SQL6 select name, sex and case. When age is missing, then 999 else and age end as a age from check2 and quit. Here the target is same for filling the missing observation in a particular variable, but the process are different. Here we using callsec and here we using case when. Now we are running this code SQL6 and log is clear, SQL6. Okay, observe here the same output with the SQL5. Yes, SQL5 also same output. Our target is same, but the procedures are different. Like this we can fill the missing values in a particular variable. Now we can apply statistics by using Proc SQL. Then how it will be? Proc SQL create table SQL7 as select what are the variables I need, name, sex and age, and sum of height as a total. For creating a new variable and for rename the variable we are just using as, and the mean of height as average, and max of height as a max, and the minimum of height as a minimum from check1, and where height not in missing, 0, missing. group by sex, order by total descending, quit. Further we discuss about these three options. First we discuss about the statistics here, and simply sum, mean, max, minimum. These are some random statistics. Now we are applying on this height variable, and the sum of height as a total, mean of height as a average, max of height as a max. Like this we can apply any statistics by using Proc SQL. Now we are running this code. Log is clear, SQL 7. Okay, like this you can get that sum, average, maximum and minimum from that particular variable. We can create a new variable with the existing variable. Got it? In the Proc SQL also we can create a new variable. Then how it will be? Proc SQL, create table SQL 8 as select starring me. It means I need all variable from that particular data set. Age into 12 as age m from check 1 quit. I am already explaining you as can be used as a rename the variables, and as can be used for the creating a new variable. Now we are running this code. Before opening dataset, log is clear, SQL 8. Yes, and simply age will be renamed by multiplying 12 with the age observations. That is an age m. Like this, you can create a new variable with the existing variables. We are checking with some random attributes. What are the attributes? Like label, length. We can apply by the Proc SQL also. Attributes. Proc SQL, create table SQL 9 as select name and label equals to name of the subject, and sex as gender. Here just a rename. Sex as represent here rename as a gender, and height label, and length equals to 5. Format, we can apply the format from the check 1 and quit. Okay, like this simply you can apply after the variable. I just write a name is there nothing but variable here and applying label for it, and simply rename and simply apply label again, and by apply length and format after the mention of variable. And we are running this code. Before opening dataset, log is clear, SQL 9. Here the name of the label is name of the subject, and for height also we are giving label height of the subject, and for sex we just rename as a gender. Like this we can apply the attributes, and we can create a new variable with the same type of observation. Then how it will be? Proc SQL, create table SQL 10 as select here the age of, nothing but it takes as an observation in particular variable, name is age. Check 1 and quit. Simply what it happened, I am explaining with the output. Log is clear, SQL 10 created, TEMA001, it become variable name and the age of, and simply in the query I give it the age of. Okay, and what does it mean? It become a one observation in a particular variable. Okay, observe here the age of name. Again I am giving is and age. Simply the age of Alfred is 14. Like this you can create a single type of observation variable. Now we are explaining about the group by having and order. Proc SQL, create table SQL 11 as select name and age, and simply we are applying same the statistics again, mean, max, minimum. Now group by sex having sum of weight greater than, GD represent the greater than 1000, and order by total descending. By the system default it's apply ascending order and quit. Here what does the mean of group by sex? Simply it grouping the observations based on the group. Whatever we give a variable here. Having is the one type of filter condition when we combination with the group by. It means having we can't able to apply single just like a where, and order is nothing but sorting. Got it? Here group by is used to grouping the observations, and having is like a filter condition combination with the group by only, and order by is nothing but sorting. Now we are running this code. Before opening dataset, log is clear. SQL 11 is created. Okay, like this, we are getting the output, and the total is greater than 1000 only here, and average or what. We are just applying the total variable in the having. Okay, first it grouping it, then after it giving 1000 above records, then order by the total descending. Here we are applying order by the total descending, but all with the same type of observation. That's why we can't able to observe the descending order here. And we have to remember the order is nothing but first we have to write a select or group by or having. We have to follow this order in the SQL. Okay, then what is an order? First one is a select. It means after creating a variable, first statement will be select. Then after that only where statement. If you apply where before select, it won't work. And then after group by, then after having, then after order by. Okay, like this we have to follow this order. First you have to write a select statement. Then after you have to write a where statement, then after only you have to write a group, then after only you have to write an having, then after you have to only write order by. We have to follow this order when you are writing query in SQL. We can filter the data in the SQL, and already we know that for the filter data we are using if and where statement, but already we know that if cannot be used in any procedure step. That's why we are just filter the data by using where statement. And for the filter we are applying some symbols. Those are represented with the GT greater than, GG greater than and equal, LT less than, LE less than or equal. It's only on numeric variables only. Proc SQL create table SQL 12 as select. These are the variables. It's nothing but a keep, just like a keep. And from check one where height greater than 60 and quit. And there is a slight difference between where and having. Okay, and having is a combination with a group by, and where we can apply singly. And one more difference, and having will be applicable on the variables, and but where will be applicable on the observations. Like this, we can apply where statement for filter the data. Log is clear. SQL 12 is created. Simply height greater than 60 here. Like this, you can apply some random filter conditions by using greater than or equal, like that, or equal. Okay, SQL 13 same variable, just like a where height less than 60 and quit SQL 13 height below the 60. And now there is another filter condition, Proc SQL, and select all the variable from check one and where age equals to 14 and quit. Log is clear. SQL 14 here. Yes, we are getting the data like this. Simply you can apply the whatever the filter condition in a where statement. Sixth one, Proc Dataset. And the definition is datasets procedure is a utility procedure that manage your SAS file. It means we can do some changes in a dataset by using proc. They are, first one is we can modify the data. It means we can add labels, we can rename the data, we can give some other formats to the variables. Then how it will be? I name it the dataset mod, set SAS help data class, and date equals to 14 Feb 2022D, and the format is YYMMDD10. Here I am creating a new variable date, and I am giving format to that particular date. Now we are running this code. Before opening dataset, log is clear. Mod, and up to wait are the existing variables, and just additionally add one new variable date with some particular date here, and I am giving a format is the YYMMDD10 data. Now we can modify this data set by using Proc Datasets. Then how it will be? Proc Datasets library equals to work. Yes, it is in a work library. And meme type is nothing but it is a data or catalog or like that. Member type we called it is a data. That's why we mentioned the data here. Yes, this is a data set, and then it is a data. And modify mod is the data set name here. Now format date
I just changed the format of date. Previously I am giving YYMMDD10 data. I am just modified date 9 format, and I am rename the variable height with the subject height, and I am giving label to the name, that is the name of the student, label to the sex, that is the gender of the student, and label to the age variable, that is the age of the student, and quit. Here there are only two procedures in a total SAS using quit at the end. Those are, one is a Proc SQL and another one is Proc Datasets. Now we are running this code. Before opening dataset, log is clear, modify was successfully for mod.data, and renaming also done. Here the label of the name is the name of the student. Here you can see the label, and for age of the student, and for the sex, gender of the student, and height will be renamed by the subject height, and the format also changed to date 9 format. Like this, we can modify the data set by using Proc Datasets. This is a one functionality of the dataset. Now here we are changing the dataset. Now you are copying this data from particular library, and you need original data as it is. It means we can remove all the labels or whatever the formats are applied to it. We just want to remove that all the labels and the formats of the existing data. Then how we remove that? Proc Datasets library equals to work. In a previous we mentioned meme type. Here meme type, instead of writing a meme type, just empty is also enough, and modify mod attrib underscore all underscore label equals to missing. It means that I am assigning label equals to missing to the all. It's just to remove all the labels, and the format also missing, and quit. Got it? We just remove all the labels and all the formats in the dataset. Yes, the modify was successful. We can only able to remove the labels and formats only. Here previously we are assigned label to the name is the name of the student, that will be removed, and for the sex also, yes, it's empty, and for age also we give a age of the student, that is also removed. Simply we can remove all formats and all the labels in the dataset by using Proc Datasets. If you want to display each and every details about a dataset, for example here we have a mod dataset. Now I want to display each and every information about this mod dataset. Then how we check that? Data details be set SAS help.class and simply run. We are just creating one dataset here. Detail, yes, it is successfully assigned. Now Proc Datasets library equals to work, and no list contents. What are the contents? Is nothing but it just shows each and every information about that particular dataset. Then data equals to detail, and quit. Where simply what is the meaning of it? I need a contents of this particular dataset. Now we are running this code. These are the each and every information about these details dataset, nothing but a class dataset here, and what is the number of observation, number of variables here, and deleted observations, no, observation length is a 40, and all the variables here, file name. Like this we can get each and every information about this particular dataset by using the Proc Dataset. Now if you want to know the each and every detailed about this all the dataset in a particular library, okay, previously I am just mentioned one particular dataset, but if you want to know the each and every dataset in a particular library, then how it will be? Proc Datasets library equals to work, no list contents, data equals to underscore all underscore. Instead of giving a detail, I am just mentioned underscore all underscore. It means what I need each and every dataset information in that particular library. Instead of using a work, you can use whatever library you want, and quit. Here we are getting the information of work library. These are the two datasets, mod and details. These are the mod and the details, and file size, the member type is a meme type is a data, and last modified, and the file name, physical name, information about that particular datasets. But if you give individually, you get a total information. We can rename the dataset name in a particular library. Then how it will be? We are just renaming the dataset in a particular library. Proc datasets library equals to work. Change mod equals to mod 21, detail equals to detail 21 quit, and just renaming the dataset here, not the variable here. I am just renaming the dataset. We are running this and simply here detailed become detailed 21, mod become mod 21. Like this we can rename the dataset also by using proc datasets. Now we can copy selected datasets from one library to another library. Like here we are in the work library, and we know that we have some particular library SAS help. Now I want some selected dataset from this library to the our work location. Got it? Then how it will be? Proc datasets empty equals to data, member type is the data, copy in equals to SAS help, then out equals to work. Select cars and class. Quit here. What does that mean here? From that particular SAS help library, I need these two datasets to the work library. Then how it will be? We are running this code. Yes, simply we are getting cars and class datasets from the SAS help to the work library. We can copy all the dataset except some particular datasets also. Here we are just selected some dataset, and we can select all the dataset except some particular. Got it? And how it will be? Proc datasets empty equals to data, member type is a meme type, then copy in equals to SAS help, out equals to work, exclude. Or you got it, the difference between the select and exclude. Select is used to select some particular datasets from that library, and exclude is used to accept this dataset from particular library. And a baseball and buy. And a quit here, and before that we have to check these two datasets are SAS help or not. And the first one is the baseball. Yes, this is the baseball, and this is the buy dataset. Now I want to each and every dataset from this SAS help except this baseball and buy. Now we are running this code. Before opening dataset log, here see this all the dataset, copying SAS help zip mail to the work zip mail. Like that we copying all the dataset except the two. If you observe clearly, the two datasets are not in this particular list here. And we are go to the B here. Here from this the BMT, BWait, only two datasets are coming from the SAS help, and what we mentioned in the exclude except baseball and buy, we check in the work library also. Here there is no baseball and buy. And why don't we check each and every dataset? Why? Because it is in the order, after A only B, and after B C. Like this the datasets will be assigned in any library. And here this is a B section, there is a no baseball and buy. Why? Because we are excluded. Not like this, we want to all the dataset without exclude and without select. We just need all the dataset from that one library to the another library. Then how it will be? All the datasets, proc datasets, library equals to SAS help, copy, out equals to work, empty equals to data, and quit here. We are running this code. And observe the logic here. Before dataset we are just exclude baseball and buy. Now what we given, we need each and every dataset from that SAS help to the work. That's why we get baseball and buy here. And there is another way to copy the data. Then how it will be? Same target but the code is different. Proc datasets empty equals to data, copy in equals to SAS help, out equals to work, and quit. Just like this. Instead of writing a select or exclude, we just keep this line and we are running remaining. It will be take all the dataset from the SAS help library. We are running this code. We are getting the same output. Why? Because previously we are getting all the data from the SAS help library. And without coding, we can do copy by manual also. Then how it will be? We are just to do manually. We are going to the SAS help and we are just right click on it and copy. We are go to the work library and right click. This is the manual way to the copy the dataset from one library to another library. We didn't write any coding here. We are just to do manually to delete particular datasets. And proc datasets lib equals to work delete, simply delete cars and class quit. Library is a work and a delete cars and class. Then we are just running this code. And where are the cars? So first we locate the cars. Here is the cars and here is the class. We are just deleting those two. Run. Cars and class are the deleted from this work library. If you check in the order C, this is from the starting of C, there is a no cars and class datasets. Up to here there is a no. There is another way to delete dataset from particular library. Then how it will be? It's not included in a proc dataset, but this is a way to delete. Proc delete data equals to work.air space dmt and run. Simply it's not a proc dataset, but this is a one way to delete datasets in a particular library. And if you want to delete the number of datasets also, simply by using space here. We are just running these two. And before that we just located where is the air and bmt. Here is the air and here is the bmt. Running this code. Air and bmt is gone. There is no bmt in the C section. Like this, we can delete some particular dataset from a library. And instead of that, if you want to delete all the dataset from particular library, it means we just delete each and every dataset in particular library. Then how it will be? Proc datasets library equals to work empty equals to data kill quit. Simply by using kill here. And one more thing you have to remember, instead of writing name type, empty is also enough. And instead of writing total library, lib also enough. Both are okay for SAS. We are running this code. We are just deleting it. Yes, each and every dataset will be gone from the work library. And we can do this by manual also. Then how it will be? For checking that, first we need a dataset in a work library. That's why I am just running this. Yes, we are getting the two dataset cars and class. Now we can delete manually. Simply select, right click, delete, okay, and select, right click, delete, okay. And this is the way to delete. And we have another way also. Then how it will be? First I am running this code to get the dataset. We are getting again two dataset. Select, here is the into mark is the delete, and select, here is the into mark, delete, okay. Like this, we can delete the dataset from particular libraries.
Seventh one, Proc Import.
The definition is to import the data from outside environment to SAS environment. And the syntax is Proc Import data file equals to file location or file path, out equals to dataset name, dbms equals to dbms type, and run. First, we import data from the Excel. What does it mean? If the data at the outside in the Excel format, now we are importing. What does it mean? We import this data to the SAS environment. Then how it will be? And before import the data from the Excel, we have to know their file tab and their extension and the dbms. What is the file type here? It is an Excel file. Then what is an extension? What does it mean extension? When we save the file, at the end it will be saved automatically XLS or XLSX. Then if the extension is XLS or XLSX, then the dbms type should be XLS or XLSX. Okay, now we write one example. Proc import data file equals to, this is the path. Here is an import to 1. Import to 1, already we have a data. When we have a data only, we have to import that to the SAS environment. And this is our import to 1 data. Now we are importing this into SAS environment. Okay, and before import the data, must and should close the data. This is the file path here, and out equals to import. What does it mean? Whatever we want the dataset name, here we have to mention here, and dbms equals to xlsx. Okay, got it? This is an Excel file, and here extension is an xlsx, then dbms also xlsx, and run. We are running this code. Before opening dataset, log is clear. The import dataset as a 9 observations are variables. Okay, import successful. Here we are getting the data, name, math, science and social. Exactly is there or not. We have to cross check. That is an import one. That is also Excel sheet. At the outside, it is in the Excel sheet. Remember it, name, math, some random marks and 10 random students. We just in the data set, in the import data set, name, math, science, social with the random marks. Are you understand what is an import? Outside it is in Excel format. Now we convert into our SAS file format simply by using Proc Import here. If the data don't have the variables names, like here one Excel file is there. In this there is no variable names. These are all observation, just like an observation here, name, some math, social, science. We don't have the variables names here. Okay, before situation we have a data with the variable names. This is a import to one data. Okay, and in the import to two data there is a no variables. If the data is like this, what we do? What happen when we import directly? Okay, first we import it directly, simply with the same procedure, same Proc Import data file and a file location. Then how we get this file location? That is also an important question here. And for getting this file location, just right click on the file, and in the properties, here we have a location. Here we just have a location, and we just copy here, we paste here, and we add file name and its extension. We have to add the file name and its extension also. Now I am giving import to 1, and dbms is an XLS. Every Excel, if the extension is XLSX, then the dbms is same for every Excel. And run. Before opening dataset, log is clear. Here variable name change, import 1. Okay, then what it consider as a variable? Simply the first observation consider as a variable here, but it's not a correct. Revant is an observation. Got it? In this type of situation, then what is the solution for it? Simply Proc Import data file is the same location, and out is an 1 underscore, and dbms is an XLS. Get names equals to no. Okay, here simply by get names option equals to no. What does it mean? It doesn't take any variable name. Okay, and it's directly give some default variable names. Then what are those? We are running this code. Flag is clear, 1 underscore. Here, what are the default variables when we apply get names equals to no in the Excel sheet? Okay, in the Excel sheet, what are those? A, B, C, D. Then where did it get this? Simply this A, B, C, D consider as a variables names. When did this happen? If we mentioned get names equals to no. Or you got it here? If the data don't have the variable, then we have to mention get names equals to no. If the Excel file have a more than one sheets, just like here we have a 3 sheets. Okay, and if you give it directly, then where it takes from? Are you got in my question? Where it takes? Is it takes a sheet 1 or sheet 2 or sheet 3? In this type of situation, there is a solution for it, and simply Proc Import data file, and a file path is an import to 3 here. File we are taking this and out equals to import to 2. dbms is the same for Excel sheets. Here I am just mention the name of the sheet. Okay, got it? I didn't mention any particular name for that. It's Excel randomly take it as a sheet 2. That's why I just mentioned this sheet 2. Then if you apply this sheet 2, I am getting the data of this one, like a Shravani, Shravanti, like these are names. If you got it in the data set, then it will be success. Enter. If you want to data from the particular sheet, then we have to mention the sheet name. We are running this code, import 2. Okay, these are the data from the import 3 Excel file in that sheet 2. Now in this Excel sheet I want to apply some particular starting position. I mean I want just from here to here like this, or from starting position 3 to 9 like that. Okay, in that situation I just want to skip to 3 like this, and I want starting from the 4. In this situation what we do, Proc Import and same import to 3. I just gave an import to 3 and out. DBMS is the same for Excel, and the sheet equals to sheet 2. In the sheet 2, data row equals to 4. Okay, then what does it mean? In that particular sheet I want data from the 4th row. Okay, I'm just running it. Log is clear. Import. We got it. From the name Shirisha we are getting data. We are just checking the data row 4 is a Shirisha or not. Okay, in the sheet 2 from the 4 Shirisha. From this name we are getting the data. Like this we can get the data from the particular starting position also. Now, and in this particular sheet, not even from particular starting position we are getting some range of values also. For example, I want to data from here to here, only the selected data only. Then how we get this particular selected data in the data set? Simply here the starting position is there A4, and up to here I want the data that is a C8. Just like if you mention these boxes names from where to where, I want to just from here to here like this, then it is an A5, and up to here it is a D10. Like this, if you mention the range, so then you get only that particular range of values only. Then how it will be? From the range of values, Proc Import, and the same import 3. From the import 3 we are getting the data out. Import 4. DBMS is same for Excel. Get names equals to no. Here the range. First the name of the sheet and the dollar symbol, and here the range A4 to D8. Enter. I got it already. I am explained how to get a range from the Excel sheet, that starting position to ending position. And here no need to mention again sheet name. Why? Because in the range itself we are mentioned the sheet name, so no need to mention the sheet name again in it. We are just running in it. Like is clear. Import 4. Got it? From the Shirisha we are getting up to only selected area. Like this we are getting some range of values also. Now we can filter the data also. Okay, while importing only we can filter the data. Then how it will be? Then what are the filter statement? If and where. Here we are just applying where here, and data file location is the same, and already I am explaining you how to get a location. Simply by the right click, properties, and a location, copy it and paste here, and type the file name and the extension, and out equals to import to a and where condition. Simply you know how to apply a filter condition, just like that where I am just applying a where condition in the out. Okay, what does it mean? After getting an import we just filter the data, and DBMS is same, and sheet equals to sheet to run to a. And what is the filter condition here? Mass greater than 60. If the name marks only greater than 60, we are checking the out file is a 2a. Got it? In the mass, I mentioned the in the mass above the 60. Got it? Like this we can apply the filter conditions also, and these are the conditions from the Excel sheet. And there is a slight difference when we import the data from the text files. What are the differences? And remember it, when we apply in the text file there is a no sheet, there is a no range of values, there is a no data row. Got it? Why? Because in the Excel sheet we have a boxes or like just like a table, but in the text document we have a plain area. Here we don't have any boxes or any lines or like that. That's why we don't have some particular conditions like sheet, data, row, range, like that we don't have in a text format. Now we check how to import the data from the text type formats, and simply from the text to document we have to remember some file DBMS names. Okay, if the file type is a delimiter, what does it mean? In the text document separation with the delimiter, then we use a DBMS as a DLM. And if the CSV file, what does it a CSV file? Comma separated values. Then the DBMS is the CSV. And if the tab file, that is also in the text format only, that is the tab. Okay, if you explain one example, you can easily understand. First one, what is a delimiter? Okay, and remember one thing, when you import the data, you have to know how it will be. It means of what? You have to open it, you have to see it how the data will be, and then only you have to import the data from the outside to the SAS environment. Here just the same data in the text format, and this is the delimiter here. The delimiter is separate the values here. Okay, in each and every value I am just separation with the delimiter and symbol here. Now in this type of situation, how we import the data from the SAS environment? In the Excel sheet there is no need of a delimiter here. That's why, because already we have a data like this in the table format. So no need to mention any delimiters or any CSV formats like this. And but in the text format we have to understand, we have to know some rules in it. Here the delimiter is and symbol here, and you can use the whatever delimiter you want. Now how we import the data? And when we import the data, file should be closed, and first we applying in the delimiter Proc Import data file, and observe here, when if the file is an Excel, then the extension is XLSX, and when it is a text document, then the extension is .txt. If the extension is the .txt with the delimiter separation, DBMS is a DLM. Are you got it? And out is an import file, and DBMS is a DLM. Why? Because data is separated with the delimiter, that too extension is a TXT extension. How we know what type of delimiter is using in it? Before import, there is a must and should, we have to open it. And delimiter already we just see, this is the delimiter we used in that particular import one, and run. Log is clear, import file. Here we are getting the data properly. Got it? We have, don't forget to mention the delimiter, and whatever the delimiter you have to use, you have just mention here. And if the file is a CSV, what is that CSV? Comma separated values, just like what here import 2 is there, and every value is separated by the comma. That's why we call as the comma separated values, CSV. Then how to do in this type of situation? Mention Proc Import data file. This is the file location, and for every type of file format, just right click it, properties, just copy the location, and after the copy the location, we must mention the file name and their extension. Got it? Now out equals to import 6, and DBMS equals to CSV. Why? Because that is the comma separated values in the data file, and that's why DBMS is a CSV. Are you got it? Then delimiter is what? Comma, and run. Log is clear, import 6. We are getting proper data here. Based on the type of data in the data file, we have to change the delimiter, we have to change the DBMS based on the text document. In the Excel sheet, the DBMS is the same, either XLS or XLSX. But in the text document, based on the delimiter value is changing, and the DBMS also changing. Now, and just like the same situation here, if the data don't have a variables names, then what is the solution here? And the solution is the same for Excel file and text file. For both, the solution is same, that is gets name equals to no. Are you got it? There is a no change, and for in the DBMS or whatever, the solution is same, just get names equals to no, that is an import to 3. Then how will the data in import to 3? Okay, here we don't have a variables names, and when we applying get names equals to no in the Excel sheet, what are the default variables names? A, B, C, D. But when we apply get names equals to no in the text document, what are the default variables? Import to 7, okay, var1, var2, var3, var4. Just like these are the default variable names when we apply get names equals to no in the text format. And here also we just restrict the data, same procedure here, and nothing is changed for restrict the data in the text file or Excel file. Process is same. We are just running this code. Or you got it? Just the text is different and it is a CSV file. That's why delimiter is a comma here, and we are run. Log is clear. Import 8. Got it? We are getting the proper data and above 60. We have to check that. Yes, in the mass above 60. Okay, like this we restrict the data, same like an Excel file. There is nothing changed when we restrict the data, either Excel or both. If you use the same file to import again and again, you just give name for that. Instead of that writing file path again and again, you just name it. Then how it will be? File name. This is the name for the path. Now the path. Okay, for the import to text format. For this, I just mention the name. I am text. Okay, we are running it, and we just give same file name for some random Excel sheet also. File name. The name of the path is I am Excel, and this is the path. Import to 1. For this, I giving a name for it. Okay. Now we are applying these two in the Proc Import. Then how it will be? If first we apply in the text file. Proc Import data file equals to I am text. Like this, we just mention the name instead of the path. And out, I am just giving a EITA, and DBMS is the same, and delimiter is the same, and log is clear. Import EITA. Like this, you get the data. Or you got it? Instead of using the file path, I am just using a file name statement here to name the path, and just like that we can apply in the Excel file also. Then how it will be? Proc Import data file equals to name of the path. And what does it here? Import 1. For the import 1, where we import to 1 here and name it the import, we just cross check both are same or not, and out import 1A, and DBMS is an XLS. Run. Okay, we are just running this code. Log is clear. Import 1A. First we check import 1. Raju, Revant, like just like this. Import 1A. Just like this. Instead of giving file path again and again, we just name for it. Already we run this import 7. Now, if you run again, it means of what? If you run this code second time, it doesn't import again. It shows one note. Then what is the note here? And here import to cancel. I am already importing import to 7 file data set, but if you run, just simply run second time, it doesn't import. Or if you do any changes here, what does it? I just mentioned get names equals to S. I am just running this second time. Then what does it give? Import to cancel. Output data set import 7 already exists. What does it mean? It cannot replace it. So we have to specify the replace option. Then how it will be? Just replace. Now we are running this. Like this, the log is clear now. 7 data was successfully created. Here we just get names equals to S. What does it mean? Again, it's take the first value as a variable here. Like this, we can use the replace option here. And if you run any file, and again, if, for example, already we are import 6, we are just run second time. Then what it shows? Import will be cancel. Just mention replace option. It will be clear. Log clear. Import 6. Got it? And if you run any import code second time, you have to use the replace option. If you understand my explanation, try to apply this tab file. I am already applying CSV file and delimiter both, and try to apply this tab file and try to mention the DBMS.
8th one, Proc Export.
And the definition is to export the data from the SAS environment to outside environment. Simply, if you have a data set in your work library or any other library in your SAS environment, export that file into as a Excel sheet, as a text document. And the syntax is Proc Export data equals to dataset name, out file equals to file location or file path, and dbms equals to dbms type. As same as the dbms type in a Proc Import, same as a export also. For that, first file type is an Excel. If the extension is XLS or XLSX, then the DBS type will be XLS or XLSX. Now first we import some simple data to the outside environment, then how it will be. Proc Export and data equals to SAS help.class. In the SAS help, we have some class dataset. Now we are export that dataset into outside environment as an Excel file. Now I just give a location here and I just give some random location to export the data, and DBMS is an XLSX and run. Got it? Then what is the difference between import and export here? In the import we have a data file, but in the export we have a out file, and in the import we have a out. In the export we have a data. That is the difference here. Now we are run this code. Before opening data set, log is clear, and we are opening. This is an export one. This is the export to one. We can export the data from the SAS environment to the outside environment by using Proc Export, and the data file name should be mentioned here. If whatever name you given it here, that will be the file name at the outside. Now how we export a data to the text format? File type, here already you know that DBMS extensions here, and if the delimiter and DBMS is the DLM, and if the CSV file, then the DBMS will be CSV, and if the tab file, then the DBMS should be tab. And now here, after creating a file at the outside, if you want to separate it with the comma, then we use the DBMS as a CSV. If you want to separate with any delimiter, you just use a DLM. Now we import the data from the SAS environment to outside as a text file. Then how it will be? Proc Export data equals to same SAS help.class, and out file I give some random location, and I want to convert as a text file. That's why I give a TXT. Before I want to convert as an Excel file, that's why I give an extension of Excel. So now I want to convert as a text, that's why I give a extension of text document. And DBMS is a CSV. What does it mean? I want data set by the comma separated values, and delimiter is a comma, and log export. And in a previous one we just export with a comma, and like that you can with any delimiter. Okay, now we are giving some random delimiter here, and then how it will be? Proc Export data equals to SAS help.class, and export, I am exporting the same data set here, and out file is just a file path, and I need a text file, that's why I give a txt, and the file name is an export3, and delimiter is a star. I just give some random delimiter, and DBMS, you know that DLM. If you use any delimiter, then the DBMS should be DLM. If you want to values separated by the comma, then you use a CSV. Now I am just applying with a star, nothing but any of the delimiter, then the log is clear. Now we are checking data is a created or not. Export 3. Okay, here data is a created with the delimiter star between the values. Like this you can export the data by any text format with any delimiter. Instead of using right again and again this file path, we just give a name to it. And if you give a name once, and you can use it number of times in a Proc Export, then how it will be? And I just giving a name to the path here. This is a path, and this is a name of that path, and this is the file name. File name of the path, and the path. And I'm just giving text to the some text, one text format and one is a Excel format. Now we are implementing it First we apply in an Excel, then how it will be. Proc Export, data is the same, SAS help, and out file equals EXXL, and here EXXL is nothing but what? This path location. Then what is that? 1A here. Okay, I am just giving a 1A to the export to file. Then how it will be, we are just check. DBMS is an XLXX, same. Now we are running. Log is clear, export successfully. And now what is that? Export 1A. We are converting as a what? Export 1A here, nothing but what? One Excel format. Yes, it is created successfully, and we are just mention what is the difference here, and everything is same. Instead of using a file, I am just giving name to that path, and simply I am mention the path here. Okay, now I am just giving file path to text format, then how it will be in the text. And Proc Export data is the same, SAS help class. Out file is equals to EXText. Then what does it mean? Instead of writing this, I am just giving this. And what is the file name? Export to 2A, and that to text format. Then how it will be. And delimiter is a star. I want to separate with a star. For the Excel, no need of delimiter. Only for the text format only, it is the need of delimiter here. Now we are running this code. Log is clear, successfully created. Now we are checking it. Export to A. If you run this code for the second time, it shows the one note. Already we export this. Now we are running this again. Then what does it shows? The export cancel. Why? Because it's a default not replace the existing data. What it shows is an already exist. Why? Because we already created export to. But if you just run, we didn't change. We are just run this code. If you run the code for the second time, it doesn't replace. At that situation, we have to mention replace manually. Now we are running this successfully created. Like this, if you run for the second time or you did any changes in a file, you need to mention the replace option. At that situation only you get the data replaced. And for now, if you understand my class, just try to apply filter condition in the export files.
Ninth one, Proc Sort.
The definition is Proc Sort is arranges the dataset by the values in an ascending order. It means if you give a character variable in a by statement, it gives in alphabetical order. And if you give a numeric variable in a by statement, it gives ascending order. For understanding about Proc Sort, we take example from SAS help.class. And I named the dataset sort, set SAS help.class and run. We are running this course. Before opening dataset, log is clear, sort. Here we have a class dataset named by the sort here. Now we are sorting this dataset by variables. Proc sort data equals to sort data, and sort is nothing but original dataset here, and by statement is used to sorting the variables and run. Before opening dataset, log is clear, and a procedure sort is used and sort. And observe here what we mentioned here by age. Simply we give by age here. It means I need observations in ascending order. Default normally it gives an ascending order, and age is a numerical variable, so it gives an ascending order. And then how it convert here? Simply it gives ascending. It means from small to high, and first give 11s, then 12s, all 12s, then 13s, then 14s, then 15s and 16s. Like this, it gives some particular order by using Proc Sort. Here by default it gives ascending order. If in case if you want a descending order, then how it will be? Proc Sort data equals to sort by descending age, and run here. And default without mention anything, it gives an ascending. Now we convert as a descending, and before opening dataset, log is clear, and sort. Okay, now it gives descending order. Descending order means from high to small. and you can give multiple variables in a by statement also. Then how it will be? Proc sort data equals to sort by sex and age and run. Observe here, previous we give only one variable, so it only gives that particular variable in ascending order, remaining convert as based on this ascending order. Now if you give a two variable, then how it will convert? Before opening dataset, log is clear, sort. Now observe here, we give a two variables in a by statement for sorting. First we give a sex, then after we give a age. First sex convert in alphabetical order, then in alphabetical order F is first, so M is second. So all the F's are coming first, then all the M's are coming next. Then again what we give, what is the second variable here? Age. Then what it happened, and in the F, only in the females it gives ascending order, and only in the males it gives ascending order. It separates the order. Like this we can give a multiple variables also. Now we can create a data set. Then how it will be? And proc sort data equals to sort simply by using out statement, just like in a frequency we give an out, and in a means also we give an out, like that. In the proc sort also, for creating same like we use the out statement here for creating a new data set, and by sex and run. Before opening data set, log is clear, and sort 1. Open sort 1, and here this is a sort 1, and it gives new data set with the sorting. We can use a dataset option as an option only. We can't able to use an as a statement in a procedures. They are draw, keep, and rename. First we apply a keep, and proc sort data equals to sort, out equals to sort k, and keep name and age, and by sex and run here. And simply we are running this. Here we are just use the keep as an option. Now we are running this code, and before opening dataset, log is clear, and sort k. And what we did, we just keep a two variables in a out, okay, and we give a two variables name and age. Next dataset option is a drop, and everything is same. Proc sort out equals to sort d drop, and by sex and run. We are just using a drop statement. Simply just like a keep, we are running this code. Before opening dataset, log is clear, sort d. Observe here what we drop name and age, and it gives the remaining. Already you know how to use a drop here. And next one is a rename. I just rename another variable, out equals to sort or, and rename sex equals to gender, and by sex and run. I just rename the existing variable with the new variable, and before opening dataset, log is clear, sort r, and sex is renamed by the gender. Like this, we can use dataset options as an option in the out statement. The another important application of proc sort is remove the duplicates. First, we have to know what is the duplicate, and at which situation we called observation as a duplicate observation. And for that, first we create a one duplicate dataset, and that is I named the dataset dup. And here I created some random variables. They are id, name, mass, and science marks. Here, observe here, these two are not a duplicates. Why? Because id is a different and a name also different. And observe here, these two are the duplicate. Why? Because same 3 and Rahul same marks are repeating again. This type of observations we call as a duplicates. Now, how to remove these duplicates? By using a proc sort. For removing duplicates, we use the no duplicates. Proc sort data equals to dup, out equals to dup1, no duplicates, and by id and run. Simply we just use the no duplicates for removing duplicates. We run this dup. Before opening dataset, log is clear, dup. Here 3 is repeating twice. That's why we called as a duplicate here. Now we are running this. Before opening dataset, log is clear, dup1. Here 3 will be removed from this dup1. Got it? Like this, we can remove the duplicates from the dataset, and instead of using no duplicates, no dupe is also enough. Everything is same, just instead of using no duplicates, no dupe is also enough. We are running this code. Before opening dataset, log is clear. Dupe to same output in the one dataset, two dataset, no duplicates, no dupe, both are same. And if you observe in the class dataset, there is a no duplicates. Why? Because no duplicates by age and run. I'm just running this code and I gave out as a sort to 1. Before opening dataset, log is clear, sort to 1. Observe here, there is a no duplicates in this dataset. Why? Because name variable differ the each and every observation in this dataset. There is a no two same names in this dataset. That's why there is a no duplicates here. And observe here, 0 duplicates, and before there is a 1 duplicate observation deleted, and here 0 duplicates. Why? Because name is different. And the next one, there is another option for removing the duplicates, that is a no dupe key. Okay, then what is the difference between no dupe and a no dupe key? And giving by the example, proc sort data equals to sort no dupe key out equals to sort to by age and run. Here the difference between no duplicates and no dupe key is, if you give a no dupe, it takes the total data set for the removing the duplicates. But if you give a no dupe key, it takes only duplicates in this by statement variable. And we are running this code. You can easily understand. Before opening dataset, log is clear. 13 observation with the duplicate key values were deleted. Sort beside of all the variables, only in age variable, if you consider these two, these are the duplicate, and if you consider these all are the duplicates. It means if you give a no dupe key, it doesn't consider each and every variable in a data set. It only consider whatever the variable is given in the by statement. Here I am giving the age, that's why it gives the unique values in the age variable. And we can create a new data set with that particular duplicates also. Then how it will be? Proc sort data equals to dupe out equals to dupe 1 duplicates dupe out equals to dupe 1 by id. And here this is the original data set, and out is nothing but without duplicates. Why? Because we are using a no duplicates, and a dupe out whatever the duplicate observations are getting into this data set. We are running this code. Before opening data set, log is clear. The first data set is the original data set, that is a dupe. Yes, here this is a duplicate, and the next one is a dupe 1 without duplicate, and a dupe 1a with duplicate. This is the duplicate observation. It means if you want to what are the duplicates in that particular data set, simply we use dupe out.
10th one, Proc Univariate.
The following are the produced by Proc Univariate, and it's more helpful for creating graphs. They are, first one is a moment. It is for n, mean, standard deviation, etc. And second one is the basic statistical measures like mean, median, mode, standard deviation, etc. And the third one, tests for location like a student sign and a signer random test, etc. And fourth one is a quantiles. It means it gives some values at a particular percentages. And the next one is an extreme observations, nothing but the lowest 5 and highest 5 values in the data set. For understanding about a Proc Univariate, we take example from SAS help.class, and I named the data set demo. We are running this code. Before opening data set, log is clear. We are opening demo. Here we have a class data set named demo, and now we are applying Proc Univariate on this data set. Now the syntax for Proc Univariate is Proc Univariate data equals to origin data semicolon var variable list semicolon and run. We are running simple code for that. Proc Univariate data equals to demo is nothing but class data set. Here var is the age and run. On age variable we are applying Proc Univariate, and we will produce the following 5 major information. Now we are running this code, and the first one is the moments, and second one is the basic control In that first one, n is nothing but number of observation, already we know, mean, standard deviation, skewness, uncorrected SS. And the second one is the basic statistical measures, and third one tests for location, and the fourth one quantiles, nothing but a certain particular percentages and the value, and fifth one is the 5 lowest values and the 5 highest values. Like this we get information. Here simply Proc Univariate is a combination of Proc Frequency and Proc Means, and Proc Univariate will done both jobs whatever done by the means and frequency with some extra information, and it's a more useful for while creating graphs. Here we have the following five types of information, but we can restrict the following. It means, for example, if you need a only movement or only tests for location or only for extreme observation, like this type of situation, we can restrict the following information. Then how it will be, and before restrict the output, we have to know some particular names for this. It means here the movement is there, but if you directly give a movement, it doesn't take. There is another name for restrict this output. Then what are those? For the movements is the movements. For the basic statistical measures, just basic measures. And a test for location, mu equals to 0, tests for location. And quantiles is just nothing but quantiles. And for extreme observations, extreme OBS. And we have to remember these codes for restrict the output. Then how it will be? ODS select. I just select a movements, got it? I need only movements in the output. Like that we can restrict the following output while creating a Proc Univariate. Now we run this code. Proc Univariate data equals to demo var age and run. We are running this code including ODS. Yes, here we are only get the movements. Why? Because I am restrict here for output. Now just like that we can restrict the another one also, and just restrict extreme observations Proc Univariate. Again you have to write the each code var age and run, and while running you have to include the ODS select also. At that situation only you get restrict the information. Like this we can restrict the output. In the Proc Univariate we can add ID also. Then how it will be? Proc Univariate data equals to demo var age and ID name and run. And while discuss about a Proc Univariate, I am already telling you that these only for the numeric data like a means. Why? Because it's a statistical for creating a graphs, and here ID you can use both the character and a numeric. Running this code, just like some additional information is getting by the ID, it did nothing here. Like transpose we have some other purpose for ID, but here it is a concept is a different for ID. And just like a Proc Means, we have a by statement, we have a class statement in a Proc Univariate also, but very slight difference here. In a Proc Means, class is used for the compare, and a by is generally it's for grouping the variables. First we do the by statement, and whenever you use by, we have to sorting it first. Data equals to demo by sex and run. And again we write a Proc Univariate data equals to demo var age and by sex and ID is the name and run. Here I am just grouping the output. And before that, how we get an output here? Based on a age variable, we are getting each and every information like a movement, basis, statistical and everything. Now I am grouping that all the information by the sex. We are just running this code with including sort. First we get sex equals to F movements, every information based on sex equals to F. Next from here sex equals to M. Now when we using by statement here, it is grouping the information. Totally is the same, it's just separate that information based on the by variable. And just like a by class also do same thing. Proc Univariate data equals to demo var age and a class sex, ID is the name and run. We are running this code. Yes, just like we are get same information based on f. Got it? From x equals to f here and x equals to m. Like this, we can grouping the information based on some particular variables. And here we are getting some extreme observation when we run Proc Univariate. Especially we can control this extreme observation. Like here we are getting 5 observation based on one variable, and like that we have a control for extreme observations. Then how it will be? Here the SAS default assign 5 highest and 5 lowest extreme observation, and here we can control that whatever the number you need. Proc Univariate data equals to demo next ROBS equals to 3, and where age ID is the name, enter. We just add next ROBS to restrict the number of observation in extreme observations. We are running this code. Previously we are getting randomly 5 observations for extreme OBS, but when we give next ROBS it only get 3 observation. Why? Because we are restrict this number of observation by next ROBS, and we can get some frequency and order just like a values. Then how it will be? Proc Univariate data equals to demo next are values where age and ID is the name, enter. We are running this code. Here we are not mentioned next ROBS. As default it gives a 5, but we can restrict here. What we restrict here? We restrict 3. That's why we are getting the value that is 11, 12, 13, only 3, and frequency first 3 lowest, first 3 highest values. Like this, we can control the observations and the values by using next ROBS and next R values. And here we can use the round. Already we know that round is the nearest value. Then how it will be? Proc Univariate data equals to demo round equals to 3, and the next ROBS equals to 4, next R value equals to 4, and where age ID is the name, enter. Here if you observe values rounded nearest to the multiple of 3, it means when we multiply with 3 we have to get the remainder is 0. That type of values are assigned here, just like a 12 we are getting remainder as a 0. For the 15 also we are getting remainder as a 0 in the total highest and lowest only, not according to the total table. These are the 5 highest and 5 lowest values. Here 11, 12, 13 is there, and there is the only one value, that is a 12 nearest to the 3. It means when we remainder is 0, and here 15 is like that. That type of, that is the meaning here, rounding the observations. Got it? And 15 also like that. In that 5 only, it's not include the total observation in a data set. Keep it in mind. And the values also like that. That is a round. Are you understand what is a round here? Simply the nearest values multiply of 3. When we multiply with it, whatever number you give, if you give a 4 or 5 or whatever number here, that's a your wish. And simply that values only, that too from the highest and lowest, whatever the 5 system default given only. In the next one already we discussed that Proc Univariate will do whatever is done by the frequency and the means. First we go with the frequency, Proc Freq. First we write a Proc Freq data equals to demo tables age, enter. We are running simple code of Proc Frequency. Here is an output. This is the output for Proc Frequency, and this will be same done by the Proc Univariate also. And try to capture it. Now we are go with the Proc Univariate. Proc Univariate data equals to demo frequency where age ID name run. We are running this code. We are just add a freq for getting the frequency information of that particular age variable. Here we are using a table. Here we are using a var. We are running this code. Here this is the frequency counts here, and this is the count is nothing but frequency here, and a cell is nothing but the percentages. Cum is nothing but cumulative percentages. And the next one we check with the means. For getting the frequency information, we just add a freq. Now we are go with the means. Proc means data equals to demo var age and run. This is a simple code for means. Now try to capture this exact information by the means. Now we run the same variable proc univariate. Then how it will be? Proc univariate data equals to demo. I am just giving a no print. Var equals to age. Var age. Output. Out equals to demo 1. Mean equals to mean age. Std equals to std age. Median equals to median age. Minimum, maximum, and n. Enter. And when we run this proc means, what are the default variables? N, mean, standard deviation, minimum, maximum. Already we discussed this. Now I am just need that same information, that is a mean equals to, this is the variable name, whatever you want you should give. And std also same. Std age, this is the user defined name. You can change whatever the name you want. Just like that, I get a mean, standard deviation, median, minimum, maximum, n. In the output, we are running this code. Before opening dataset, log is clear, demo 1. We are getting the same values, n, 19, mean, standard deviation, and age, and median, minimum. Minimum is 11, we know that. Maximum is 16, we know that. Median is 13, and standard deviation, and a mean, and n. Like this, we get the information whatever we get from the means also. Here we are getting only one variable information, and if you want to more than one variable, that is also same, but a small change, that is a proc univariate data equals to demo, no print. I don't need an output for this, that's why I give a no print. Var space age space height. I just mentioned another variable, just like a means also we are same mentioned another variable like this, and output out demo 2, and here mean equals to mean age space mean height. No need to write again a mean, just write a mean space age, another variable. If you want another, you just mention here another variable, you just add another variable. And the standard deviation also like that, median, minimum, maximum, n, and run. And whenever you increase the number of variables in a var, you have to increase the number of variable here also. We are running this code. Before opening dataset, log is clear, demo 2. Yes, this is the n of age. N of both are same, that's why because both are coming from the same dataset. Age mean is different, we know that. Height mean also different. And if you have a doubt about it, cross compare to the means on a height, and again check with the univariate, you get the same result. Now we can control the quantiles also. What does quantiles here? It gives the values at some particular system defined percentages. But if you need between 50 and 75, the 60 is there. If you need that value, or at a 26 like that, what is the value at the 26 percentage, like that you get information also. Then how to restrict that particular percentages. Proc univariate data equals to demo, no print. I just give a no print. Var age output out equals to demo 3, mean equals to mean age. I am just adding some extra statistics here, mean, median, standard deviation. PCT LPTS equals to, I want value at 25, at 55, at 95. Got it? Then next, PCT LPRE is nothing but the variable name. Whatever you mention here, that will be reflect in the variable name. Now we are running this code. Before opening dataset, log is clear, and demo 3. Yes, at 25 is a 12, at 55 is a 14, at 95 is the value is 16. We are just a cross check with the 25 and 95 percentages, is the value same or not. At the 25 is a 12, at 95 is a 16. Keep remember it, 25 12, 95 16. We cross check with an output. At 25 is a 12, at 95 is a 16. And like this you can get wherever the percentage you want. And just like that we get not only a single variable, we can get the number of variables percentages at a time in a single data set. Then how it will be? Proc univariate data equals to demo, no print. Var age and height, I am just getting age and height percentages at some 25 95, and data equals to demo 4. I am just adding some extra statistics. Now PCT LPTS is the same, and PCT LPRE equals to first variable name include with the age underscore, and the next height will be included, height underscore. Now we are running this code. Before opening dataset, lag is clear, demo 4. Yes, you get age 25 is a 12, height 25 is a 57.5. We are not running this height statistics, and 55 age, 55 height. Like this, you get some particular percentage values. And if you need each and every numeric variable in a data set, then how it will be? Proc Univariate data equals to demo and just run. When we mention var is used to restrict the variable here. Whatever the variable you need, we just use in the var statement. But when you ignore the var, it includes the all numeric variables in a particular data set. Then yes, here it is start. First one is an age. We are getting total age information, and here is a height. And already we know that in a demo data set we are only 3 numeric variables, that are the age, height and weight. And in the output also we are getting like that. First age is completed, next one height, the next one go with the weight. Like this, if you ignoring the var statement, it includes the all numeric variables from a data set. And already we discussed that it's a most helpful in a graphs. Then how it will be? For graphs, Proc Univariate data equals to demo var height and histogram height and run. This is a one type of graph, and like this we can use the Proc Univariate.
11th one, Proc Append.
The definition is Proc Append is adds the observation from one data set to the end of another data set. Syntax is Proc Append base equals to base data set, data equals to dataset to append, semicolon and run. There are two situations while append datasets to one another. The first one is variables are same in two datasets, and the second one is variables are different in two datasets. Now first we go with the first condition. Variables are same in two datasets. For that I am creating a two datasets with the same variables and different observations. I created a dataset with the name same one, and I created some random variables like a name, math, science, social, just like a student list, and the cards, and giving some random names and their marks, Robert, Rahim and run. This is my first dataset for append, run. Before opening dataset, lag is clear. Here is the same one dataset with the variables name, math, science and social with the random students with the random marks. At the same way, I am created another dataset with the same variable names with different observations, and I named the dataset same to input. Same variables, already we mentioned variables are same in two datasets, and the cards. These are the different observations compared to the first dataset, and we are running this code. Before opening dataset, lag is clear, same too. This is our second dataset to append. Now firstly, what is an append? What will happen when we append two datasets? And simply here this is the same one, this is the same two. And when we append data sets, the base data set become like this. Got it? Here in this proc append, we are not creating another data set. It means we are not creating a new data set. We just add one data set to the another. Whatever we given data set in a base, that will be the first, and whatever the data set in the data, that will be the bottom observations. And if you apply proc append on these two data sets, the output will become like this. Now we go to the proc append. First data set as a base, proc append base equals to same one and data equals to same two, and simply run. I'm just running this code. And in the proc append, there is a no out statement for creating a new data set here. Clearly observe here, appending work dot same to same one. Same two we are giving in the data, same one we are giving in the base. So what is in the log? Same two to same one. We are opening same one. Up to here, this is the same one data set, and it's just add at the bottom same to data set. And in the same to, data is an as it is. Data is a not change in the same to. Why? Because we are giving that same to in the data. Keep in mind, whatever data set we giving in a base, that will be the first data set. Whatever the data set, keep in mind, whatever data set we given in the base, that will be the first or upper data set, and whatever the data set we given in the data, that will be lower or bottom data set. And here this data set is just adding at the bottom to this. And here what we mentioned, first data set as a base. Now we go with the second data set as a base. Before that we have to run it again. Why? Because same one is added by the same two. We are just running again this two, and the same one and the same two as it is. Now we go with the second data set as a base. Proc Append, base equals to same two, data equals to same one, and run. Now what we given here in the base, we are giving same two. It means same two is in the upper and same one is in the bottom. We are just running this code. Before opening data set, log is clear, same two. Same one is an upper, same two is at the bottom, and the same one is as it is. Why? Because we are giving same one in the data. And here one more thing is there. If you run it twice, what will happen? Why? Because now in the same one, this is the data set. In the same two, it's already added the same one. Now it is the same one. If you run twice, again what happened? Again same two as a base, same one as a data. We are just running this code. Log is clear. Again we are opening same two. Yes. What happened here? It's add twice. Got it? Up to here, this is the Raven. Start at Raven, and this is the Raven. And if you run another time, what happened? Again it is the same two data set. This is the same two data set, whatever it is. And this is the same one data set, and if you run again it's add at the bottom of that data set. We are running this again. Before opening data set, log is clear. Again we are opening same two. We are giving same two in the base. Okay, now it's a start with a Raven, 1 time, 2 times, 3 times. Like this, if you once run, it will add at the bottom of another data set. If you run twice it added. Like that, if you run the number of times, it will be added at the times. I am just giving key to remember what is the first data set, what is the bottom data set. Simply here, base. In the alphabet, B is the first. In the alphabet, after B, we give a D. Just like that, B is the first. So this is the first data set. Data, whatever we given in the data, that is a bottom data set. Remember like this, you will never forget. This is the first situation. Now we go with second situation. That is variables are different in two data sets. Then what we do at that type of situation? And for this I am creating two data sets with the two different variables. I name the data set diff1, giving some random variables and cards and some random marks with the same students. Enter. This is my first data set. Before opening data set, log is clear, diff1 is created. Yes, this is the diff1. Now I am creating another data set here, diff2, and with a different variable. Here the subjects are math, science, social. Here the subjects are Telugu, Hindi, English. Cards, same students with a different marks. I am running this code. Okay, before opening data set, log is clear, diff2. Here is diff2 is created with the different variables here. Got it? Here the variables are math, science, social. Here the variables are Telugu, Hindi, English. Now we are trying to append, then what will happen? First data set as a base, just like before one. And a proc append. Base equals to diff1, whatever we given in a base, that is the first one, and data equals to down. No appending done because of anomalies listed above. Use force option to append this file. The log says itself use force option. Now we are using force option. We're just running this code. Log. Now check. It just thrown a warning. What is that? These variables, first data set variables are not in a second data set. Second data set variables are not in a first data set. But we get an output. then how it will be. And in the base we are giving a diff1, so check diff1. These columns are missing. Why? Because these subjects don't have a marks in math, science, social. Now we go with the second condition, that is the second data set as a base. Before that we have to rerun. Why? Because the diff1 already changed when we run a proc append. Now we go with the second data set as a base. Proc append, base equals to diff2, data equals to diff1. Force is a must and should be used. When the data sets are with the different variables, we have to use the force. Enter. We're just running this code. Before opening data set, log is clear with some warnings, and this for now this is negligible, and we are opening diff2. In the diff2 they have a Telugu marks, but in the dataset 1, in the diff 1, they don't have a Telugu, Hindi, English mark. That's why they're giving missing. We can use a proc append as a statement also. Then how it will be? Append as a statement. In the proc datasets, lib equals to work, no list, append. Append is a statement here. Base equals to diff 1. Here also same condition, whatever we giving in a base, that is the first one. Data is the down, second one. Force, wait. Why we are using force here in the proc datasets also? Why? Because there are different variables in the datasets. Before running in it, first we have to rerun this. Why? Because diff2 is a change when we run a proc append. Now we run in this code. Before opening dataset, log is clear, and we give a base in diff1, so we are opening just like the same output. Append as a statement also.
12th one, Proc Copy.
The definition is Proc Copy is used to transfer files or datasets from one library to another library. And the syntax is Proc Copy in equals to origin library, out equals to target library, meme type equals to type of data, run. In the Proc Copy, first we transfer selected file from one library to another library. Then how it will be? Particular datasets. Proc Copy in equals to SAS help, out equals to work. I want to move datasets from SAS help to the work. Meme type equals to data, nothing but member type, and select class and cars and run. It means I need only two datasets from SAS help to the work library. We are running this code. Before opening dataset, log is clear. Copying SAS help class to work class and SAS help cars to work cars. We go to the library, work library. Here we are getting two dataset, class and cars. From the SAS help to the work library. In the next one, we can exclude some particular data sets from one library to another library. It means when we copying all the data sets from one library to another library, I just want to restrict some particular data set. For example, here BMT is there and a by is there. I want to restrict these two data set while transfer dataset from one library to another library. Then how it will be? Proc Copy in equals to SAS help, out equals to work, meme type is nothing but member type equals to data, that is a dataset, that's why it is a data. Exclude BMT and by and run. It means I don't want these two datasets to transfer. We are running this code. We go to the work library. Yes, we are getting all the data sets from SAS help to the work library except that by and BMT. And we know that in these libraries the data set will be arranged based on alphabetical order, and yes, here it is a start B and here it is the end B, and these two are not included in it. Here we are using the select and exclude statement. For select is used for select, exclude is used to restrict. Now if you ignore these two statements, it means if you directly run, then all the data sets are transferred from one library to another library. Proc Copy in equals to SAS help, out equals to work, empty. Instead of giving meme type, just empty also enough. Consider empty also, same like a meme type, and run. Here we are not include any select or exclude here, and simply you know that if you run this BMT and by will be included. Why? Because previously we are excluding these two. Now we run this code, simply we know that all the data sets will be coming or not, And observe here BMT and by is include now. Why? Because we are not restrict any data sets here. That's why when we run by and BMT also included. And here proc copy is a procedure and a copy we can use as a statement also. Then how it will be? Proc datasets. Not in a proc copy. Proc copy is a procedure. And in a proc datasets we can use copy as a statement. Lib equals to SAS help, copy, out equals to work, and empty equals to data, and quit. We know that in the dataset we use a quit. And before run this code, first we have to delete all the dataset from the work library. How to clean it? And we know that how to clean the work library. Proc datasets lib work till quit. Now we are running this code. Copy as a statement. We are not exclude or include anything here. Here we are getting all the data sets from SAS help to the work library. Like this, you can copy the files from one library to another library by using proc copy. Till now, we have transferred datasets from one library to another library. And the same like a dataset, we have a catalogs in the SAS help library. And these are the catalogs, and when we create a format, the catalogs will be created. And if you want to move that separately catalog from one library to another library, then what is the code for that? And before that we have to confirm work library is an empty. Now we are moving that catalogs, only catalogs from one library to another library. The code is simple, very small change here. Proc copy in equals to SAS help, out equals to work, and here empty equals to catalog and run. And previously transfer datasets from one library to another library. That's why empty equals to data. And here if you want to move a catalog, then member type equals to catalog. Now we are running this code. Like this, we can transfer catalogs from one library to another library.
13th one, Proc Printto.
And the definition is the Printto procedure defines destination or route for output and log to user specified locations. Simply to save or export log and output from SAS environment to external locations. First, we export log from SAS environment to external location. For that, first I am creating log. It means I just write some random programs that are test from the SAS help class and a SAS help class check and a SAS help.pmt. These are some random programs just for log. Why? Because before it log is an empty and I am just running some random programs. Here we are getting log. This is our log. Now I want to save or export this log to external location. Proc Printto log equals to, this is a location, then from where we get this location. For that, first we have to create a folder at the outside. I am creating that folder at the desktop. Then how it will be, already you know. Right click, new folder, and I am creating name with the dummy. Now I want to save files, whatever files are log and output at this location. For that, what we have to do, just right click, properties, and copy this location, go to the SAS environment and paste here. Mention the name of that folder. What is that? Just a dummy. And now the name for that log file, this is a user defined, whatever you mention, and I just mentioned testing, and the extension is log. For the log file, keep in mind, for the log file extension is .log. Now we run this Proc Printto with the programs and running successful. And now we go to the dummy. Yes, here the dummy file, and here we have a testing log. And yes, this is our log. Whenever you want to export the log to external location, we have to write Proc Printto at starting, then after that coding. In this way, we are export log file to the external location, and a simple Proc Printto log up to here location, and this is the folder name, and this is our file name, and this is our user specified name, and the extension is .log for the log files. Now for the output, first I am creating some output, proc print data equals to test, and just output this class dataset. I am running it, and this is our output. Now I want to move this output as it is to the external location. Then how it will be for that? And here same as the Proc Printto, instead of log we just use the print for the output, and the location is same, up to location is same, and this is a user defined name, and for the output extension is .lst, and for the log extension is a .log, and for the output extension is .lst. And we are running this code, and here log. Now we go to the location dummy and checking .lst, and it's opening in the only SAS environment. And there is another way to export or save log and output from SAS environment to external location, that is simply by using dm statement. And first we export log dm log semicolon file, and this is the location. Already you know that how to take a location from the folder, and this is the name of the folder, and this is our user defined name, and log and a replace. Here if you run twice, the replace must and should, and keep in mind one inverted comma is starting here and ending here, and one is for the location, and here semicolon is a must and should, and here is a semicolon must and should. Now before that, for sometimes if you run this code, just look at here, log is not printing here. Up to here this is the previous one, and we are running this dm statement, but the log for the dm statement is not reflected in the real-time scenario. At some time log is a blank. What we do in that situation, simply we run proc printto. We are running this. Now we are running this dm. Now check log, it is clear. Now we go for the location, that is a dummy already we created in the desktop, that is a dummy, and we named test dm. Yes, this is our log file. Our result is same, just it is another way. Instead of using a proc Printto, use the dm statement also enough. And for the output, same dm output file and the location. Now I am giving name for that output is check dm, and extension is .lst for the output. Already we explained about it, and a replace is a must and should if you run twice. Now we are running this code. Yes, here it's a printed. Now we go to the location dummy, and what we given check dm.ls.
14th one, Proc Print.
The definition is Proc Print prints a listing of values of some or all of the variables, and the syntax is Proc Print data equals to origin data and run. For explain about Proc Print, we take example from SAS help.class, and I named the dataset check and set SAS help.class and run. We are running this code. Before opening dataset, log is clear. We are opening check. Here this is the class dataset, and I named the dataset check. Now we are applying Proc Print, and here Proc Print, we know that Proc Print is nothing but it's just to display dataset in the output window, and whatever you did in a Proc Print, it doesn't affect the original dataset. And we have some options, and we have some statements in a Proc Print. First we go with an options. In the Proc Print, we can apply options and the statements. Before going with the options, first we print a normal dataset, that is a check. Here we are printing the dataset in the output. It is opening in the output window, and here there is a number of observation OBS is there, and the first option is we can restrict the number of observation in the output window. And then how it will be? Simply by using OBS equals to 10. It means I need only 10 observations. Then it prints only 10 observations. Here already I am telling you that whatever we did in a proc print, it doesn't affect the original data set. Here I just restrict the 10 observation, but in the check data set there will nothing change in it. Like this we can restrict the number of observations. And the next one, here in the output window we are getting OBS, and if you want to eliminate that, we can simply using no OBS and run. Simply I am using no OBS to eliminate the observations column. We are running this code. Previously it have an OBS, and if you give no OBS, it's eliminate or neglect the OBS. If you want to give a space between this observation, simply we use Proc print data equals to check, and we use the double and run. Simply I am giving double to give a space between the observations. Here there is no space between an observation. Now we are just running the double option. Yes, like this we get the space between the observations, and this is a space here, and previously we don't have a space between observation, but when we give double, it gives a space between the observations. And just like that we give a more width. It means between the variables. Proc print data equals to check, width equals to full. I am just giving width equals to full, and I am running this code. Here I am giving width equals to full. It gives a more space between the variables. And if you give, and the next one, we know the dataset options, keep, drop, rename. We can also use that. Then how it will be? First one is the keep as an option and run. I am just keep 3 variables here, just like that. We can keep. And the next one, drop. We can drop some variables also. Drop. I am just dropping the remaining variables of age and sex. And the next one we can also rename here and run. So we are running this code. Here we are renaming the variable sex as a gender, but when we opening original data set, check the sex as a sex. It means it doesn't impact on the original data set. It's a just display purpose only. And the next one is the statements. Then what are those? In that first one is a var. Var to restrict the variable, just like a keep and drop. Whatever the variables you mentioned in a var, that will be keep. Whatever the variable you skip in it, that will become drop. Then how it will be? Var age, name and a sex and run. And just a keep, just like a keep. Yes, age, name and a sex. And the next one is ID. ID is used to identify each entity. Then how it will be? Data equals to check var age, name and sex. Just restrict the variable ID age. And here the variable age is in var and age in ID. Then we check the output how it is. Simply here age is repeated. And what is an age here? To identify each entity, or nothing but to identify each observation, just like a position of that observation. And the next one, we can filter the data. How it will be? Just using a where. We can't use if statement in any procedure step. Already we know that we just using where here, and var age, and where age equals to 14. I'm just filter the data, only age equals to 14. And these are the options and statements in a proc print. And
15th one, Proc Compare.
Definition is Proc Compare is used to compare the observations and variables in 2 different datasets. And the syntax is Proc Compare base equals to base dataset, compare equals to dataset to compare, and run. For understand Proc Compare, I am explaining some real-time situations for better understand. In that, the first situation is 2 data set with the same variables and same observations. and what it given in the result when the two data set have a same variables and a same observation. For that, I am creating a two data sets with the same variables with a different data set name. This is a check 1, this is a check 2, and the variables are name, mass, science, social, name, mass, science, social, and here observations also different, name, and here is the names, and just like each and everything is the same in two data sets. Now how to compare? According to the syntax, proc compare base equals to check 1, this is the base data set, and compare equals to data set to compare, this is the compare data set. Now I'm comparing check 2 with the check 1, and we are running this code. Now this is the result of when the two data set have a same observations and the variables here, and this is the data set name, and a work dot, it means that the library is a work, and data set name, and a created when it's a created, and a modified number of observations and number of variables, and a variable summary. Number of variables in common is 4. In that it means in two data set 4 common variables are there, and this is about observations. Number of observations in common is 5 observations, and the total number of observation in check 1 is the 5, check 2 is the 5, and number of observation with some compared variables unequal. This is an important, when we compare with the data it should be unequal, and the number of observation with all compared variables equals to 5. And you know that in the real-time scenario where if you QC, you compare your data with the production, okay, and in the base we give a production, in the compare we give a QC data, and here it should be unequal. And this is the final situation, just like we need to get this type of result when we compare two data set. This is the result. And the second situation is two data set with different variables and observations. Okay, then what does it mean? Here math, science, social is there, math, science, biology is there. Got it? Different variables. Yes, this is the different variables. Here it have a name, math, science, social, and here it have a name, math, science, and biology. And observations also. Here the social observations are 58, 89, 69, 45, 65, but here biology are the different. Names are same. Then what happened in this type of situation? Same. Proc compare base equals to check 1, compare equals to check 2, and run. We are running this code. Okay, here what we get same like a before one. Number of variables and observations are same, and but we didn't get any mismatches. We know that here it is a social, it is a biology, but check the result is the same, just like a previous one. This is a previous one or summary, and here this is a present one, but there is a no difference. We have to know where we get a difference. For that we have to mention two options. Those are list where, list on. Now check the difference in the result. Now what is the result? What is the difference in result here? Listing of variables, social in check 1 but not in check 2, and biology in check 2 but not in check 1. But here unequal is 0. Are you get my point? Unequal is 0 here. Keep in mind what is the situation here. Unequal is 0, and what it mentioned, this variable not in this one, this variable not in this one. We know that this is not a fair, but we get a note unequal equals to 0. Then why we get this unequal equals to 0? And the SAS only do that, it compares the variables and observation. Here social variable is there, but here it don't have a social variable, and here biology variable is there, and here biology not here. That's why when it compare, what it given result, simply this variable not in this one, this variable not in this one, but unequal is not is there. Got it? And this is the one situation when the two data set with the different variables and observations. And the third situation, two data set with the same variables and different observation. What is the situation 2? Two data set with different variables and different observations. Now the situation is variable is same but observations are different. Then these are the two data set here. Observe here, mass, science, social and name variables are same, but what is the different here? Observations are different. In a social subject, observations are different. Check here, this is the 58, here is the 63, 89, 23 and here is the 45, here is the missing. Then how we get Proc compare, base equals to check 1, compare equals to check 2, list all list where is a mandatory. Now we run this code. Now check here, number of observation is different. Here number of observations are 5 in a check 1, but in a check 2 number of observations are 4. This is the different. And number of variables in common is 4. Comparison result, observation 5 in check 1 but not in check 2. And here unequal is 4. And here number of variables compare with the sum observation unequal is, and here unequal is 4. What are those 4? 4 observations in one variable. Got it? Let's check here, number of observations with some compared variables unequal is 4. Number of observation compared with some observation unequals to 1. This is a variable summary. This is an observation summary. 4 observations are unequal. One variable in one variable, that is an unequal. And these are the values that are where we get an unequal. Here 58, here is 63 is there. Same variable social and social. 89, 23, 69, like this we are getting differences. In this type of situation, if you want to know the exact observation for identity, already you know that for identity we use the ID variable and we just mentioned a name. Now we check the what we get result. At Revant, Rahul, Raju and Rahim, these are the ID. Already you know that ID is used to identify the each entity here, and here ID is used to identify the particular observation where we get a difference. And here is check height 4, length 4. This is in the social variable we have a differences, and a missing differences is the one missing differences, and number of differences is 4. And observe here in the second situation we get unequal equals to 0. But in the third situations we get unequal is 4 and unequal is the 1. Why we get this type of result? Why? Because what we'll do in a proc compare. Proc compare is compare the variables and observation, and when it get differences are unequal, two data set with the same variable but in different observation, only we get this type of output, unequal is 1. But simply if the variables are not in a common, it gives like this. This variable is not in this one and this variable not in this one. Here we give only one variable. In the real time scenario, commonly we get a number of variables are mismatches, number of observation mismatches. Situation is same. And the next situation is two data set with the different variables but same observations. Then what the data sets are, these are the data set, observations are same but here variables are different. Here math, science, biology, here is the social. Now we are comparing this. Proc compare, base equals to check 1, compare equals to check 2, list and list where, and we are running this code. Same type of same, just like a S2, different variables and observations. In a S4 also same, different variables, and when the data is with the different variables, it just give listing of variables. Just this variable is not in this one, it doesn't compare the observations. Keep in mind, if the variable is different, then it doesn't compare with the another variable, and it's a compare when the two variables are same, just like a situation 3. And the next situation is two data set with the number of different variables and different observations also. Then the data is check 1, different variables, yes, different variables, and data also different. I mean the number of observation I am mentioning here, number of observations. Got it? Number of different variables, number of different observations. Number, here 4 observation is there, here the 5 observations are there. Okay, here 5 variables are there, here 4 variables are there. Then how we get the data in this type of situation? Previously we are comparing the same number of observations and same number of variables, but in that observations are different. But here the number is here, we are checking with the number. If the variables and observations are different, it's just given here only. We don't know where we get that particular differences. And here number of variables is different and number of observations also different. But we didn't get where is exactly get the differences, and that exactly differences only when we get same variables. Here this is the same variables, but the observations are different. While comparing, the first task is comparing the number of observations and number of variables. Then the next task is we have to remove this type of nodes. Then finally, if you get any differences like this, we have to
16th one, Proc Report.
And definition is Proc Report combines feature of the print, means and tabulate procedure with the features of the data step in a single report writing tool that can produce a variety of reports. It means whatever we did with the Proc print, means and a tabulate, it can be done by a single procedure, that is Proc Report. And the syntax is Proc Report data equals to tables, column, list of variables, semicolon, define variable / action and run. For explaining about Proc Report, I am creating one dummy data set and I named the data set with the report here, and the variables are country and it's a region, and the product, it's a wooden product, month of product made, and a predict rate, actual rate and product type. And these are that, and I am taking the two countries, Canada and Germany, and the region west, east and west, and these are some random made products, and these are the months, and these are a predict rate, this is an actual rate, and the product type, it's a furniture office or just like that. Now we are running this code. Before opening data set, log is clear, we are opening report. This is our data set. Now we are applying Proc Report. Already we discussed whatever done by Proc Print and means and tabulates, it will be done with a single procedure, that is a Proc Report. Now we are applying Proc Report on it, and in the real-time scenario for creating Proc Report, they give us a mock shell to generate a report as it is. According to the syntax, I am writing a simple code, Proc Report data equals to report, and these are the lines node WD, headline and head skip for the report display. And these are here one note is no W must end should. It means don't use OWD, N will be must. And a column already we discussed the word list of variables, and here whatever the order you need in the report, you have to maintain that order here. It means first in the report I need a country, then after that region of product, predict, actual, just like that. You have to maintain the order whatever you want in the report. And here column is a nothing but to just restrict the variables. And the next one, define. Here the variable country, I just grouping that country. And the next define region, I am just grouping the region also, and run. Now we are running this code. This is a simple report country, and just grouping the country and grouping the region and product, predict and actual, and this is the order we are mentioned in the column. In the report here we have a values, and we can do summarize at the end of the table also. Then how it will be, and what is the statement for that? That is an or break to summarize at the end of the report. Here this is an end of the report. Here we can summarize this the total values. Then for that, Proc Report data equals to report. This is a must and should, headline and skip and missing, and a column country, region, product, predict and actual. I need just this adder, and define country as a group, same, define region as a group, and define predict as a mean, and simply mentioned mean, we can find the mean for that particular variable. And R break after, summarize, underline, overline. Got it? If you give a UL, that is an underline. If you give an OL, that is an overline. And we just mentioned summarize and R break after. Now check. This is the previous one, and now this is the present one by using R break after, summarize, overline. Break after. It means to give break after a particular variable. For example, I need a calculation after a country. It means after a Canada and after a Germany. Here this is the overall summarization. But I need a country wise. For that we use break after. Remaining is same. We do some simple change. Define country as a group, region as a group, define predict as a mean, break after country. Here R break after means at the end. We can give a break after particular variable, and here I want to break after a country, and the summarize is for summarize the values and run. Just like here we are getting the summarization after a particular variable. Here we have mentioned a country. That's why in the country there are two types, that is a Canada and a Germany, and all the Canada values will be summarized at once, all the Germany values are summarized at once. If you have a more than one type of variable, for example here is an India is there, then after India it will be calculated like that. And here if you want to remove this particular name Canada here, it is easily possible to remove that. Germany, Canada is there, already we know that it is a Canada, and if you want to skip this Canada name here at particular this area, then how it will be? Simply one simple option is there for that, to remove break value. What is the break value here? Whatever the name here, the country, that is a Canada, we can remove that also. Then how it will be? Remaining is same, column is the same, whatever order you need just mention, and define country as a group, region as a group, predict mean, and break after country just is same. What is the difference here? This suppress option. If you use the suppress option, whatever the name here, it will be skip and run. The name will be skip by using suppress option. And the next one is break before, and we have a break after. Break before is just opposite to the break after. Break after gives break after a particular variable. Break before gives break before a particular variable. Okay, then how it will be? And these are the same. And what happened when we skip these? You just check. Define country as a group, region as a group. I just mean for the predict variable. This is a numeric variable, you know that. And break before. Very simple change. Break after means after a variable. Break before means before a variable. Simple change. Summarize, skip. And why we use the suppress? I don't need that name on that. And run. We check the result. Yes. Break before. It means before a Canada and before a Germany. Got it? Like this, we get the result break before and break after and R break. These are the three values to summarize the values, to summarize the variables. And we have another option, that is an across. Okay, then how it will work? Proc report, data equals to report, and the remaining same. Column, I just need a country, region, predict, actual. Want to skip the product here. And define country as a group, I just grouping the country, grouping the region, and define across. And define predict. In the predict, I just find a mean, and R break after. I am using the R break after. It means at the end I need a summarization value, and run. And instead of just a group, here if you want to across, then what is an across? You just check the result. Here across means we are mentioned in the region as a across. Then it find the values of whatever the region values is here, east and west. Before that, where is an east and west? In the region it have a east and west. And when we mentioned across in a particular variable, we get the summarization for that particular variable also. And before that, we are region, we are grouping the region also, and we mentioned across here region. And if you mention across the predict will be here, and now instead of using across, we just mentioned by comma operator also. Comma operator for across, same. Proc report options are same, and column country after region I need across. For that I just using a comma here, and define country as a group, region as a group, predict as a mean, or break after, summarize, skip, and run. Here in the region I mentioned across. Now we check the result. In the region east predict, west predict. And what is the difference between these two? What happened when we mentioned a comma here? Here this is a without comma operator. Okay, east west. And when we use comma operator, east predict, west predict, then why we get like that? Why? Because we using comma before a predict. And here in the report, here region is there. The area of the region, what are the variables in that particular region? For that we just using a splitting header. What is that? And options are same. Column I'm just mentioned in a predict and actual in the bracket. Define country as a group, region as a group, and the across I'm just mentioned this line up to on the region variable, and define predict as a mean, or break after I need a summarization at the end, and run. Just check the result. These are the variables on the region, and the area, whatever the area is covered, that will be region variables. And check here, this is the normal across we use here, and if you use the comma, it will be mentioned like this. We can use a splitting header across that variable. Yes, and this is about using of across. What across would do, and it can do summarization in the particular variable, and we can use a comma operator for that also, and we can use a splitting head also. And the next one, compute. Compute columns means we can do some calculation on a variable. Next one is a computing columns. Simply we can do some calculation on a particular variables, and we can create a new variable with that calculation also. Then how it will be? Proc report data equals to report, options are same. Column I need these all variables report, and define country as an order, and just mention order, region as an order, and define month. On the month I just order MON, and order equals to data. Order is nothing but just put in an order, sorting order. And if you mention a group, it is a grouping the variable, and if you mention across, it across the variables. Display, however the variable is there in a data set. And the next one, actual also just a display as it is. And the next one, here define diff computed. Okay, I am explaining after total writing of code. Compute diff equals to predict minus actual. These are only two numerical variables we have in the data set. And end count and run. Here we want to do the calculation between the predict and actual. We just do subtraction between these two variables. Before that, we have to mention before the variable name. I want to name that new variable as a diff. So we have to mention before it's a define in the column statement, and here we have to define that in the diff also. We have to mention that variable in the define statement also. Or you got it? Whatever the variable you want to create a new, that will be mentioned in the column statement first, then again in the define statement also. In the diff it will be computed. Now we are computing, and whatever the format if you want to apply, you just apply on it. And the next one, compute. I want to compute diff. And what is the diff? Diff equals to predict minus actual and end count. It is also mandatory. Now we are running this code just like this. Here we are just a diff. This is the subtraction of predict and actual. Here we are getting a value. Okay, like this. While computing, what are the important points? Whatever you want to do calculation on a variable, first you have to mention that new creating variable name in a column and in the define statement also. and a compute diff. This is a new variable name. Here you do calculation and end cap. And now we can do computing column based on the statistics also. Then how it will be? Proc report remaining is same column, and here already I mentioned the main variable in the column, and define country as a group, region as a group, predict as a mean, actual as a sum. Here the statistics are mean and sum. Now I want to do calculation on these two variables, finding variables, and the define diff is a computed. And next one compute diff, and diff equals to predict dot mean. What does it mean? Whatever we get mean values on a predict, that will be mentioned here. And the next one actual dot sum. Whatever the values we are getting in an actual variable, we are calculating here. And end cap, and here I need a break after country. I just do summarization after break after country, and R break bottom of the values, and R break country at a particular variable also, and run. Check here, this is the R break, this is the break after values, and what we mentioned diff as a computed variable here diff, and whatever the values we are getting in the mean and sum, that will be difference. And you can do not only diff, you can do any calculation on that particular variables by using compute. And the next one is a line statement. Then how we use the line statement? Proc report data equals to report, and the options are same. And the column I just mentioned new variable here ratio. For that I need a compute on that ratio, and define ratio as a computed, and just mentioned a format, and R break after summarize. I just need to summarize the values at the bottom of the values, and a compute ratio. I'm just finding the values of a ratio here. Actual dot sum. I just did both the sum values, and end cap compute after country. And here line at the rate 10. I just want to add a line, that is country ratio is a ratio. Whatever the value we get in the ratio, that will be highlighted here in this particular line. I'm just adding a line, and end cap, and run. What you want to mention for the line statement here, compute after country. After country I just want the line. What is that line? Line, I just mentioned the length of that line, and country ratio is, that is the length here for these lines, and the ratio, whatever the value we get in this particular variable, that will be highlighted here, and skip. We are running this code. Country ratio is, what is the ratio value? 1.26. okay, and country ratio is, this is the Canada country ratio, this is the Germany country ratio. This is the summarization value, not these are not ratio values. Okay, and the next one is call define function. Then how we use the call define function in the report, and options are same, column is the same. I just again I'm finding this another new variable ratio, and define country, region, both I'm just mentioned both variables in a one define, that is also same we are getting, and define ratio, break after country, R break after, I'm just using a both after in a particular variable, and at the bottom of the report, and compute ratio, I'm just finding the ratio, and if ratio greater than 1, I'm just writing for the call define, then call define call style equals to foreground equals to red. I need just a color red, and if ratio is less than 0.9 or greater than 1.1, then call define, I'm just mentioned call underscore call, and a style here, whatever the style you need, just mention it, and end cap, run. If you use a SAS 9.4, we are not getting that colors and everything in the report. But if you use a SAS Enterprise or Universal Studio, you get that colors, all this in the report. Here we are not getting any colors or any bold variables here. And we can rename that particular variables in the report also. Then how it will be? Proc report, data equals to report, options are same. I'm just mentioned that some variables in the column. Define country as a group, region as a group. I just mentioned predict mean, and I just rename with this single inverted commas, and actual mean, this is the rename. Whatever you want to rename, you just mentioned in the single quoted. We are running this code. here predict dot means and actual dot mean. Like this we can rename the variables also. And here we can apply some particular formats also. For that, first we are creating a proc format, and continent Canada equals to CA, Germany equals to GR. I am just creating a one particular format. I am running this format. Now how we apply this format in a report? Proc report data equals to report. Options are same, column is same, whatever the value variables you need, just to mention in that order also. And different country group format. Before that also we are just apply format, just like this you can apply whatever the format you want in the define statement only. And define predict as a mean, actual as a mean, and just like instead of Canada we get a CA, Germany instead of Germany we are getting a GR. Just like this you can apply any format whatever you want. And we have some header options here, okay, but this is a SAS 9.4. we are not getting any colors or any styles in the report. If you use the enterprise guide or Universal Studio, you may get that result properly, but the code is same. Code is a without syntax errors or everything. Proc report data equals to report. Options are same. I just mentioned a split, header and column. These are the variables, and I just mentioned the group with like this, and a predict, define country as a group, region across, already we discussed about across, and define production type across, and a break after, R break after, I am using R break after, and first we get a group. For all column, wherever we mentioned a group in the region, in the production type, I just want this group. That's why in the output we are getting for the region and product. For the across also, I just need these lines. That's why we are getting these lines. And I am using R break after. That's why we are getting the summarization at the bottom of the page, at the bottom of the report. And the next one is a splitting by slash. Here we are not getting these also in the report, but the code without errors. Country, and I just predict equal to predict man, actual equals to actual mean, and define country as a group, actual as a sum, actual by total, and these are the predict mean. These are the new variables I want to define in it. Here I just rename that predict as a predict total, actual mean here. Okay, here predict in the place of predict, I just rename that predict mean. Actual in the place, I just need actual mean. Like that we are getting the report also. But by the here we are not get a slash. Why? Because in this report we are not getting that output. And the next one is the styles. Again the styles also not getting in the SAS 9.4, and options are same. Style equals to header. I just need a header is a Roman, and a column region, and a country region, and here in the region I need a Korea, and R break after summarize. Style equals to, for the R break after I need a bold and run. These are all styles are not included in a SAS 9.4. If you use any enterprise guide and everything, it will be display the result as it is. Please subscribe my channel, click the bell icon, like the video and comment below, share with your friends. Thank you, support me.